Okay, for high HQL, you uh, especially for those who want to take the Testing. Good morning. Can you hear me? Yeah, thank you, Darren. We got only three people here. But anyway, let's start first. I think they are going to join in gradually. Uh, so, uh, Yesterday we finished five module from module 6 to 11 because I swapped module 10 for today. So a quick review, and then hopefully more people will join soon, and then we discuss other topic. Uh, Yesterday we talked about module 6, the EML. Actually, almost whole day EML is the Hadoop cluster on AWS. Hadoop help us that we can process. We don't need the expensive hardware. We don't need the share storage. Just very cheap hard disk, and then we can analyze not only structured data but also unstructured data. And AWS, the version of Hadoop, actually is EMR, Elastic MapReduce. More than 10 years before, a lot of people use MapReduce, but nowadays people tend to use the Hive, the Pig, and some other open source programming language. And together with Spark, Spark is very famous. In some of our project, they use Spark for many years already. And Spark got new enhancement. We will talk about that yeah, in this next module. So yesterday we talked about EML, Hive, Pig, and also the web interface. Just like in your lab, you use the hood together with Pig. And then we also discuss the Glue. The three features provided by Glue is data catalog, okay, so that we can have the metadata, meta store, and then we can also do the ETL job, all right, and then job orchestration. Okay, so today we start from module 10 first, and then we will once again we will have a lab, but I will move this lab together with the lunch hour, so that 1 hour lab, 45 minutes for doing this lab. And then today's agenda, since we already cover module 11, so yeah, after Spark, we will start talking about Redshift, okay, the data warehouse. And then maybe in the morning, we can start talking about security. And around 12:30, we have the lunch together with the lab. And then we talk about course visualization. The last module just it feels like some big data architecture example. All right, not really a lot of content, just some example. And then we will complete the class so that all of you will get the attendance cert, okay, and complete the class, okay. So that's the arrangement. Remember, the lab, you can do the lab until 11:45 p.m. Okay, after that, you cannot access the lab. And the Slack resources, you still can ask me question tomorrow, next week, until the last day of September. All right. After the last day of September, I will remove the group. You cannot access the Slack anymore. So please download anything that you need, the link, the files that we share. All right. So that's the arrangement. Let's start talking about Spark. So this is module 10, and then we will go to module 12. Spark, we have a lab on Spark. Yeah, first of all, Spark, we, if you want to find document, okay, as I said yesterday, the creator of Spark set up a company, okay, the name is Databricks. So in order to download the documentation, learn more, we go to this website, Databricks. Okay, still a lot of the materials, especially the document, is free of charge. You just go to Spark, the database.com, all right, and then you can go to documentation page, introduction to Spark. There are many materials. Okay, what is Spark? What are the requirements? And then the notebook, data set, how we load the data, how we use the SQL. Okay, now they have more than 2,000 staff. All right, a very big company already. So not only AWS, but some other cloud like Azure or Google, they also use Databricks resources, Spark resources. But we call it Apache Spark, and we have a lab so that you can try see what we can do. Spark is very famous because we can support batch processing and also stream processing, machine learning, interactive. Okay, and we can leverage memory together with this. So it is very flexible. You can use SQL statement, you can use Python, you can use the supported language. So that's why it's famous. And EMR, actually, one checkbox, you can have the Spark install when you launch the cluster. And then you don't need to pay extra because EMR already you pay for those EC2 instance. Okay, so that's why a lot of people use Spark. Yeah, let's take a look on this topic. And Spark now the version is 3.0. I just share a link in earlier this morning related to the version. Okay, if you go to this page, this is the EMR 6 point something release version. Okay, the latest is 6.3. Yeah, and then you can check all the version. Say for example, if you create 6.0 EMR cluster, all right, Hadoop is already 3.2.1, and then if you take a look on Spark, not only Spark but others, still using 2.4. Okay, and then if you use 6.1, 6.2, 6.3 is the latest. They are using newer version of Spark. Okay, you can refer this document. Just now, Darren asked a question, what is the meaning of orange color? Just change. Okay, you see 5.1 to 5.2, there is change, then it's represented by orange color. Because, yeah, many open source project, all right, just like yesterday, we mentioned Clang, Flink, Hook, Hive, then here is the list that you can refer. Okay, so for if you're using the very old EML 4 dot something, you still can create. They are using Spark 1.0, all right, and 5 dot something, 6.0, Spark 2.4, 2.0, 2.4. Okay, so 6.1 EML 3.0. Okay, so what's the difference? You can take a look in 3.0. Generally, once again, is announced last year. All right, 2020. Okay, yeah, as you can see, they get some research inside Spark, around 50, a half still using a SQL. Okay, but some other say 4% use streaming, say 7% use Python Spark, something like that. You can take a look. But the enhancement mainly on the speed side. Okay, so if you compare, if a Spark announced this in their blog, in their official page, databricks.com, by using 2.4, the time to process 30 terabyte data, okay, it takes 12, 13 hour. Okay, if you can take a look here. And then if you use 3.0 half time, okay, so it's much faster. But the technology, you can refer to the document. Let me just post this link into our Slack group so that you can have further reading. Okay. And the other one. One thing I also need to mention, after this class, you should get the completion cert, right? But in order to get the completion cert, you need to register into the class before the lunch hour, all right? most of you already finished the registration, but one of you didn't finish yet. So he is not here. But Timothy, if you heard that, please ask Tech, because the administrator in Beijing said that he didn't register into the class. So use this link. Actually, you should receive in the email sent from Beijing. Ask Tech to do the registration before lunch hour. Okay, Timothy, can you help? All right. So this is important in order to get the attendance up. Okay, let's keep going. And then, yeah, Spark official document, go to Databricks, go to documentation. The motivation, this module we talk about Spark, you are going to do the lab for lab 6, okay, working with Spark, look and feel, and then the use case, the advantage of using Spark. So once again, a lot of module is about data processing. Okay, since day one, Athena, yesterday, all day, related to the EMR, and then Spark, still processing. Okay, after that, we will talk about Redshift, cost security, and then visualization. Okay, so motivation, actually Spark support in-memory analytic. Okay, and yesterday we mentioned one programming framework also use in-memory is Presto. But what's the difference? For Presto, we need to load all the data into memory. That's why it is not very scalable. You may have 1 terabyte memory, but you may have 100 terabyte data. Okay, so yeah, in that case, and Presto, we only support SQL daemon. Okay, so as we mentioned, SQL daemon is not very rich on transformation. And then Spark, we support memory, but we also support the disk. Okay, so you may have some data in memory, some data on disk. It means that it is very scalable. Okay, you may have really 10, 100, thousands of terabyte data. Okay, and we will talk about what is acyclic data flow a little bit later. Okay, it means tracking anything fail that we can resume. Okay, we will have some diagram talking about that. So here we support a wide range of analytics like machine learning, graph. We support R, Python, Excel, the tools, just the tools. We support batch processing, interactive, and then streaming as well. We support almost everything, okay, related to the big data world. All right. So the MapReduce is slow nowadays if we talk comparing with Spark, because MapReduce, we have the input data, likely they are from the disk, and then we do the map. As we mentioned, there is still some other phase like shuffle, like split, okay? But normally we just focus on the two big process, map and reduce. And after that, you have intermediate data, all right, stored in the Hadoop file system. And then you get from intermediate data, do the reduce job, and then output. So this is a lot of IOPS, okay? So normally the bottleneck will be in the hard disk because CPU memory is super fast, okay? But hard disk, a lot of read the data, write the data, read the data, write the data. So it slows down the process. In memory is much faster in that scenario. So that's why Apache Spark, yeah, let's take a look on some understanding first. In-memory data mining, all right? We can query super big data set, okay, because we can also leverage the hard disk, okay, very fast. And we will talk about RDD. RDD actually start from 1.0. Since day one of Spark, we have RDD. RDD is actually, as you can see here, resilience. As in most cases, the Spark run on Hadoop cluster, but this is not a must, not necessary. You can install Spark in your notebook, in your laptop. All right. But in your notebook, there is no distributed processing. Okay, as the whole course, we talk about distributed processing, parallel processing. Okay, RDD is basically redundant. So if you got this is the node in AWS, it's EC2 on-prem, maybe hardware or other virtual machine. So you got some memory, all right? It is not a single port copy, okay? It will have a redundance, okay? So if one node go down, you will not lose your data. That's resilient. And distributed, it means that we leverage all the node to have the parallel process, okay? And those data set is stored in memory, okay? This is a read-only copy, read-only. Suppose you modify, you transform, you create something, it will create another RDD, okay? The RDD is since 1.0, and it supports structure and unstructured data, okay? So that's why very powerful. In memory or from this, okay? If you got really a large data set, you may have some data on this, some data in memory, but still faster than MapReduce. Generally, maybe 10 times faster than only this usage, this storage. Okay, so faster than Hive, faster than MapReduce. Okay, so Spark, as we mentioned, we support a wide range of programming framework, and then for different process. Okay, as you can see from Databricks official report, around half of people still using Spark SQL. Streaming around 4%. Okay, some other around 8, 10%. You can take a look on the report. Okay, we have their own machine learning, GraphX, their graph database. Okay, so we support batch processing, interactive streaming. Okay, so everything. And then we support text file or the data stored in Hadoop file system, or S3, okay, or other data store, okay, like the relational database. We also support connecting to Redshift, okay, a wide range of support. So for Spark programming model, what we just talked about is RDD, read-only, distributed, okay, data object tested in memory across all the nodes. If one node goes down, you will not lose your data because resilience, we got multiple copy and we leverage the distributed processing, okay, in memory, okay. And then we can reuse this Spark, and like MapReduce, we support fault tolerance, we support scalability, okay. Even those data in memory because we got multiple copy. So in Spark, what people normally do, like other programming framework, we transform the data. Okay, we support MapReduce. Other, we also support filtering, group by, join. Okay, this is just some example. And then for action, we can do count, collect, or save to some other storage, do the reduce. So let's take a look on an example. All right. So this example, first of all, we talk about, we got something called DAG, direct acyclic graph. What does that mean? It provides linear the tracking, okay, lineage tracking. It means that suppose we got multiple nodes to do the process. Some node may fail, everything may fail because of the network error, the operating system hang, the hardware issue. So we got the tracking because some data is in memory. Maybe we process in the middle. If it fail, we don't need to do everything again. We can resume from like certain checkpoint. Okay, that's the tracking. And because our data in memory, we minimize the I/O. All right, and then inside Spark, they have partition aware. They will not have two copy inside a single node. All right, and then yeah, that's what the built-in they have. Let's take a look in this example. Go back to here. We support map, filter, group by, join, transformation. Here you see map, filter, group by, join. Okay, just do all the transformation. Let's start from the beginning here. Okay, so first of all, suppose you already stage one have some RDD, just cache content, cache object in your memory, maybe structured, maybe unstructured. Okay, it doesn't matter. So we may perform some transformation, maybe we group them, okay, do some group aggregation, whatever. All right. So in that scenario, maybe you want to join together with other table, like this is related to the country you sold, this is related to your product you sold, whatever. So we have maybe another RDD, okay, and then here we do some mapping, do some filtering. All right. So from here, the stage one, this RDD to the other RDD, after we finish group by, we form another RDD. As we mentioned, the RDD is read-only. Okay, we are not modifying the data inside, but we form a new RDD. Okay, so it consumes memory. By using Spark, you should use on AWS the memory focused instance type, like the R instance type and then the X instance type. And make sure that you don't consume all the memory. You may scale out, you may change to a larger instance type. Monitor the memory usage as well. Okay, Gangler can help you, or you can install the CloudWatch agent and then monitor in CloudWatch. So this is inside memory, structure, unstructured. Okay, so if one node goes down, say for example, because distributed, you may use parallel processing 10 node to process this whole flow or diagram, not a single node. So if one node goes down, since we got tracking, we can resume here. We don't need to do everything. We start the whole job again. That's the usage of RDD. Okay, and the tracking. And then for Spark library, we since that's 1.0, RDD is from 1.0. All right, Spark. Since 2.0, they have some enhancement. The enhancement is called data frame. Okay, data frame is structure. Okay, not for unstructured. If you still have unstructured data, please use the RDD. Okay, now, but you have choice. Suppose you got structured data, all right, columns and row. As you can see, this is very structured. Okay, name, age, gender, maybe product, telephone, address, whatever. Okay, so data frame, we map the column together with the data, just like the data warehouse. All right, so this is data frame. Okay, by using the new 2.x data frame, actually since 2.x, we have free API endpoint. Okay, you can use RDD API endpoint. Okay, suppose the data is still unstructured, or you can use data frame. Okay, or use a high level called dataset API. All right, so the dataset API, you can work for both RDD and data frame. But remember, data frame is structure, and data frame we don't support the strong type safety. All right, so we recommend that you use the dataset API. All right, but for develop those, please refer to the official Databricks documentation. We can do group join, filter, map, just like what we mentioned. And then here, because unstructured, we may leverage the, say for example, Lambda function, high level programming, and then expression. Okay, so and Spark SQL, we can use, most people still using Spark SQL, all right, SQL statement, okay, to query those data on memory, in memory on this, all right. We support Hive Metastore. Inside Spark, we have Hive Metastore. But of course, you can, on AWS, you can use Glue. We support a wide range of format, all right. Pacrid that we mentioned, ORC, JSON, okay, JDBC, database connection. And then you can write user-defined function. When connect to the endpoint, you can use the ODBC, JDBC. So we support a wide range of connector. Okay. So for stream, yeah, as you see in the report last year, 4% of the people use Spark Stream, the streaming, just like the Kinesis Kafka, but in Spark, yeah, we once again, actually, they are not truly real-time stream. As we mentioned before, they are just micro batch. We buffer, okay, to certain megabyte or time windowing, okay, every 5 minutes, and then we send and process those data, okay. And we support Python, Java, Scala, and they have the streaming API that you can connect. All right. So if you want to process stream data, you can use Spark. A lot of choice. Okay. So machine learning inside Spark, they also have their own machine learning library. Okay, that you can work with Python, Scala, Java, Spark R, etc. Okay, but AWS, the other choice, of course, you can use the SageMaker provided by AWS or provided by Spark. If you develop this machine learning from Spark, then likely you refer to their documentation. Okay. So graphics, remember, day one we talk about in AWS, we have the LabTool related to the graph database, the node, and the relations. Okay, in Spark we have something similar. There are graphics, yeah, that you have the library to develop those graph database. Okay, once again, refer to their documentation. Okay, you can run it inside EMR. So you can also run Hive on Spark, but once again, this is less likely. All right, Hive can be run on MapReduce if you are still using Hadoop 1.x. Can be run on Spark, less likely. But now, if you run directly on the newest EMR version, we run on TAS instead. So this one is more likely. Okay, or if you just have ad hoc query, you run it on Athena nowadays. Okay, so a lot of choice running Spark QL. All right, just SQL tools. Normally, once again, we use Hive to query the data. The focus is query rather than transformation. So by using Spark, the reason is much faster than MapReduce, and you can run it inside Hadoop. Okay, yeah, of course, you can run it also in other platform, like in your laptop. They have just standalone client side, normally for testing, but in production environment, we better have the distributed processing. Okay, we support batch interactive stream, but under the cover, micro batch. This is micro batch. All right, micro batch. All right, so let's keep going. And then the reason of running Apache Spark, yeah, we support a wide range of data source, just like we support S3, DynamoDB, and then Redshift, and destination. Okay, we support ODBC, JDBC. They have API endpoint for you to connect RDD, data frame, or dataset, high-level API. And then we support SQL, Python, Java. So if you're already familiar with this language, you don't need to learn new things. Okay. And then compute incentive, because use a lot of memory. Okay, a lot of resources. To be more specific, is memory. Okay, so you might need more memory instance type. Okay, but the performance gain, but it really depends whether you have performance gain on MapReduce, because you can still leverage hard disk. If most data in hard disk, maybe not so much performance gain. So depends on how you use, but it could be much faster. According to Databricks documentation, 10 times faster. And streaming actually is micro batch that we discussed, just like the file host. And then the benefit, we talked about this before, but let's elaborate a little bit more here. That's young. Okay, the Spark nowadays still also using Yarn, And if you're using Hadoop 3.0, we are using Yarn version 2, much faster once again. And then here in the Hadoop cluster, the gray color is Hadoop cluster. And then this is the master node. Okay, your application connect to the master node. All right, and then you may use interactive the POM or submit the job, and then you got your worker node, I should say core node in AWS, and then the task node. Once again, we got the application master. You submit the job, the Yarn will launch those application master. All right, and the application master only will be appear when you run the job. After you finish the job, the application master will go away. All right, so you got 10 job, there will be 10 application master. All right, and then let me get back my pen. Okay, so actually Yarn help us to create those Yarn container in the core node or task node. All right, and then the application master pastes those tasks inside those container. Suppose application master got failed or the container got failed, actually the Yarn will relaunch these resources. If the task fail, this is the responsibility of the application master to paste the task and run it retry again. And then, as we mentioned, since we are using Spark, a lot of cache. Okay, you paste your task, actually the job, and then work together with the cache, the RDD, unstructured structured data, or the data frame. Okay, relatively structured. Okay, and then execute the task. As you can see, a lot of container and maybe run on a lot of node so that it is parallel process. One node goes down, the linear tracking, okay, resume from somewhere, not from scratch. Okay, so after you finish your result, maybe you have new RDD, and then using some other connector, you can save the result to Redshift, to DynamoDB, to S3, wherever. All right, so that's how it works under the cover. All right, but you can write your programming like before Spark SQL or Spark using Python, using Java, streaming, okay, your micro-batch, okay, to do your job, do your development. Okay, so in together with EMR, it's basically the same. In on-prem, you install the Spark program yourself. Now, in AWS, you just check the box. When you launch the cluster, you select a better advanced, and then check the box. They will install everything, the application master, the daemon node, install everything for you. You don't need to do the configuration. Just check one box. And under the cover, they are using Yarn. Okay, if you are 2.0 Spark, they likely running on Yarn version 1. If Spark 3 dot something, likely because the Hadoop cluster is 3 dot something also, we are using actually the Yarn version 2. Okay, a newer update, faster engine. Okay, so we can get the source and then interact with the master node, and of course parallel process the result we save back to somewhere else. Okay, once again, better not save in the Hadoop file system so that we can terminate the EML cluster if you don't need it. So the storage that we support a wide range of AWS storage. S3 likely, since we are using EML, that's EML FS. Okay, it means that it's stored externally, not inside the Hadoop file system. And then we can also support likely using the connector save to Redshift. Next module, we are going to talk about Redshift. And then we can save to, normally Kinesis is basically the data ingress. As we mentioned in module 2 and 3, we got the agent. If you are Linux machine, if you are using the producer, you can install in Windows machine, Mac machine, the producer library, or you can use the API call SDK develop. Okay, more control, but more coding. And then ingress and then process the result saved to somewhere else. We can connect to DynamoDB and then also RDS. But likely, RDS, this is online transactional processing. Likely, this, in many cases, is the data source. Okay, after you process, you save to S3 Redshift. Okay, normally this the target. Okay, in Redshift, because you keep appending those data, become historical data, and then you analyze from here. All right. Also, we can connect to Elasticsearch. Yeah, so you can save actually from everywhere. We can also leverage the Glue catalog. Okay, suppose those data on S3, just like yesterday, we scan suggest the schema provided by the Glue catalog. All right, and then yeah, that's the supported storage. Okay, so the benefit of Spark is easy to use, they suggest, but still maybe some documentation, some learning. All right, and then you can deploy in a very small environment. Once again, Spark not necessary run on EMR, run on Hadoop. You can use a client-like test version installed in your laptop. All right, and then container. All right, this is container managed environment. But actually, you don't need to care about that running in EMR. You don't need to install the Docker container, use the Docker command, something like that. Okay, you just run your task using Spark. Spark will do everything else for you. And then automatic logging to S3 for further analyze and debug. Okay, and the cost. Many people talk about cost. We have a module talking about cost. Spark on EMR, no additional cost. Okay, because you just pay for the EMR computing resources. Okay, how many EC2, what is the size? So you can increase CPU memory, but actually here you increase the instance type or add more node, then it will also add some cost. But you can also use the reserve instance, the spot instance as well. All right, tightly integrated with AWS. Not just AWS, but also some other open source engine. You can work together with Angular. Take a look on the memory usage. CloudWatch, you can even install the agent to capture those custom metrics. Okay, and then set alarm if necessary. And then use the EMR FS, that data physically stored in S3. Okay, so yeah, that's some benefit related to Spark. Okay, let's keep going. And then for monitoring, once again, Spark got its own UI. You can take a look there. But more or less, there's focus on job level. Is your job success, fail? But for metrics, we can take a look on CloudWatch. CPU, memory. But memory, once again, by default, we don't capture any memory usage inside CloudWatch. You need the custom metrics, install the agent, do some configuration, specify a JSON file, what you want to capture, or memory usage, and then send back to CloudWatch. And then you can get those custom metrics. And you can do some notification. That's actually alarm. The CPU, the memory over 85% for 2 hours, then notification. Okay. Once again, in cloud, you better fix the problem automatically. Maybe automatically add some more node so that you got more memory, and then notify the admin. Okay, rather than manually ask the admin to take action. Okay, we better use automatic approach. Okay, in the cloud environment. So this module, let's take a look on the module review that the Spark we paste MapReduce. The answer is false because we can in the same EMR cluster, MapReduce is already there. Okay, you can use Spark, but you can still have some other job, maybe less important. I don't care. They use the disk and run longer and use MapReduce. Inside the same EMR, you can run really a lot of different programming framework. Okay, some tasks still MapReduce, some tasks Spark, some tasks Hive, some tasks Presto. Okay, depends. All right. So the four major module inside Spark, most people still using Spark SQL. Okay, and then as we saw, 4% use Spark streaming. ML and graph around 8, 10%, something like that. You can take a look on the page that I shared to you. And then running Spark actually some benefit. Okay, easy to use if you're already familiar with JSON Python. All right, interactive. Yeah, and so maybe you don't need to learn much. And then container management. Okay, but you don't need to care about the container. Spark Yarn will care about that. Integrated with AWS other service. Low cost. I should say low cost. No extra cost if you are using already EML. All right. So this the advantage of using Spark. And Lab 6, you will try the Spark. Once again, we put it in the lunch hour. All right. Just like the New York tax data, all right, transformation company want to analyze, all right, the tax go around the New York City, different time. Yeah, so the lab focus is you got some raw data, and then inside EML. Yesterday, one of the lab you spin up the EML yourself, all right, and then we also work together with the Redshift. Okay, you will touch a little bit on Redshift, and then after that, you use Spark to do the data processing. The results saved to Redshift, and then at the end, you can see the data from a dashboard, from S3. Actually, in the middle, they use machine learning, but we don't need to write all those models. All right, it's already there. Okay, when they spin up the cluster. Okay, if you're interested, you can go there and take a look. But yeah, we don't need to touch this side. Okay, so this is related to Spark. Give it a try. See if you got any questions. Okay. Does anyone got any questions related to Spark? Once again, tech is tech here. If tech is not here, his colleagues, please tell tech to register into the class. All right. So let's keep Elvin. Elvin, can you hear me? Elvin, are you colleagues of? Yeah, Elvin. Please remind tech to do the class registration. Otherwise, he cannot get the certification. Okay, please do it before lunch. Okay, Elvin or Timothy, please pass this message to Ted. Let me type. Okay, you got my message. Okay, before 12 o'clock noon. All right, because I need to ask my administrator in Beijing class admin to close the class. After that, he cannot register anymore. All right, Tech didn't do the registration yet. Okay, so let's keep going. Next module is Redshift. I like this module very much. I like Redshift very much. Actually, I deliver a lot of Redshift training, not only in Hong Kong. I help US, Europe deliver many times. I still have another upcoming class in October talking about Redshift, 3-day course. Let me just show you here. If you're interested, yeah, and have budget, you can, once again, I posted already this link in the Slack, sorry. And then big data on AWS is our class now. And then let me make it larger. Okay, data warehouse could be another 3-day course. Mainly focus on Redshift, one product. Okay, actually, you can integrate with a lot of other product like Kinesis, like S3 is tightly integrated with Redshift. There is a self-paced lab. This is very good. Okay, I show you once more. If you want to try Redshift, but you don't want to pay, all right, any free resources, okay, there is, if you go to this introduction to Redshift 40-minute self-paced lab, okay, and then this link, you can see actually from QuickLab, not in our training material. It is open to public. You search introduction to Amazon Redshift. It is free of charge. It's similar to our lab. All right, you just go inside, start. You can do 100 times, 1,000,000 times because it's free of charge. All right, you can do it tomorrow, next week, next month. Okay, actually provision a new Redshift cluster. Okay, so you can try using this link. Very good material. So let me talk about Redshift. I know some of you may be interested in Redshift. Redshift is a data warehouse solution. Okay, it's totally different from other database like RDS, DynamoDB, Elasticache, etc. All right. So first of all, very interesting. Why we call it Redshift? Okay, I can tell you why. I really did some research because traditionally Amazon, okay, maybe 15, 20 years before, also use Oracle. Okay, and then you can see Oracle, the color is red. Okay, Redshift means leave this imply, leave those big giant red company and shift to this data warehouse. Okay, Amazon, AWS shift, and then customer can also shift together to this data warehouse. Let me talk a little bit background related to Redshift. Actually, Redshift is originally developed by this company. I can post the link here. Yeah, understand a little bit background so that you will be easier to understand why they do it. Okay, so Paracel is another company in California focused on data warehouse. Okay, they use the open source Postgres database. Okay, they do a lot of things. One big project is they do use the PostgreSQL. PostgreSQL is open source, actually for online transactional processing. Okay, and this is not enterprise ready. Okay, and totally not for data warehouse, but this Paracel company use the Postgres, do a lot of modification, okay, to make it enterprise ready, to change it to be data warehouse. And then, as you can see here, around 2012, okay, Amazon buy this technology, and not buying the whole company, just buys this technology because at that time Amazon AWS thinking about, I want to develop a database warehouse, a data warehouse. Sorry, I don't want to do everything from scratch, so just acquire those technology. Okay, and then after some time development, and then 2013 announced this Redshift technology. So Redshift born in 2013, already 8 years. Okay, and after AWS released generally available this technology, it is no longer open source. All right, it is a product, a service provided by AWS. So they use a lot of effort to make it data warehouse. Okay, data warehouse means we mainly focus on online analytic processing. Okay, comparing with online transactional processing. Transactional processing focus on the data now. Okay, now what do we have now? And then a lot of concurrent connection, maybe thousands or even million. Okay, a lot of people doing insert, update, delete. All right, and then analytic processing focus on historical. Okay, could be last year, could be from the beginning to yesterday to last minute. All right, past 2 weeks, okay? And then we use those data to make a beautiful report, to answer the question, to make decision, all right? And in this case, we don't likely have millions of concurrent access, maybe just 10, 100 manager, okay, consume, okay, those data and make report, okay, not for a lot of concurrent access, okay, but the data is very large, okay. You may ask the question, for the past 10 years, all right, which product I sell most, which country I sell most, what are the most likely target customer, all right. So there is really a lot of data, okay, inside. And then every day you got new transaction and keep append those data inside Redshift, okay, inside this data warehouse. Let's take a look. Actually, this module, a lot of slide is, I will say, just marketing slide. They're totally not technical. But in the 3 days data warehouse training, the first day, the first module, I will do a demo. I'm not going to do the demo here because launch the cluster and then spin up and then do the query. It takes almost an hour, all right, to get everything ready. But I got some screen capture. I just show you the result. Let me show you the result here. The screen capture. Okay. Now, let me show you some screen capture when I teach data warehouse. Yeah, I just put this picture, screen capture, into Slack. Okay. So let's take a look on this picture, the screen capture. What I will do is, as I said, I should take a look on picture 1 first. Okay, this is picture 1. This is picture 2. This is picture 3. Okay. What I typically do in data warehouse training is that, let me use a pen to draw. Okay. So, as I said, Redshift originally based on Progress, but of course, in a lot of changing, no longer Progress. Okay. From AWS, if you want to read documentation, always refer to AWS Redshift documentation. Don't look at those Progress documentation. All right. So what I will do is I will spin up a Progress database. Just create an EC2 instance, install the Progress SQL inside, okay, and then create a table, insert some data. And this machine, normally I will select a more powerful machine. Maybe I forgot 2 CPU, maybe 16 gig RAM, something like that. CPU, 2 CPU, and then maybe 4 CPU I will select. And then I will spin up a Redshift cluster with just one node. All right, that one node maybe 2 CPU and 15 gig RAM. Okay, the cheapest machine inside Redshift. Redshift we can have more than 100. Okay, nowadays 128 node work together to serve a single database. Okay, the database, the data across 128 node. So this machine is more powerful, but it's using EC2 and Progress SQL. And this one is Redshift. And then what I did is exactly the same. Here I create a table. Okay, here I create a table. And then I insert 2 records. Okay, the record just have 4 columns. The name, ID, a telephone number, something like that. And then what I did is I will keep duplicate the data. All right. Duplicate means originally I will just use a SQL statement, insert from here to the same table, insert from here to the same table. So my record will be 2, 4, 8, 16, 32, etc. If you play Mahjong, Okay, you should be very good on that. Okay, I'll do it in both sides. And let's take a look on the result. So uh, this is some screen capture in data warehouse. I will actually do the whole demo. All right. Yeah, as you can see here, if I insert from customer, select from customer, insert into the same table, okay, it means two record. For Redshift, originally, it takes 400 milliseconds, all right, 400 milliseconds, almost half a second. And then if you use Progress on EC2, all right, and then it takes less than 1 millisecond, okay, and then I keep doing that, okay, until 16 record, okay, 49 millisecond, here, 1 millisecond. So the conclusion here at the moment is that if your database is so small, do not use Redshift. All right. If you just got 100, okay, 1,000 record, do not use Redshift. Okay. And let's take a look what happened if we keep going. Okay. Next page. Uh, Let me remove the existing drawing. This is the next page. Yeah. If we go to this around yeah, 65,000, okay, 71 millisecond, okay, and this one 100 millisecond. Already Redshift is faster, okay, as you can see here. This is 71, this is 105, and you keep double, keep going. Okay, you see this is 500,000 record, okay, 500,000 record. And the next page I show you. Okay, keep doubling those data, and then until let's say here, okay, you can see it takes more than a minute to insert 33 million record. Here, just 7 seconds. Okay. The conclusion is that if you got huge database, more and more data, all right, even your EC2 is more powerful than Redshift because we got more CPU here, more memory here. Okay, the database engine cannot keep up. Progress is not enterprise ready. Okay, suppose you got billions of record, you got terabyte of data. You can find that Redshift is still doing much better. Okay, so AWS invests a lot of technology features into Redshift so that let me say a little bit. First of all, Redshift is columnar storage. We talk about that. Progress is role-based. And Redshift, the important concept is we have parallel processing. All right. Even if you got one node, right? I got one node, right? I have two CPU, I have 15 gig RAM. In Redshift, we have something called slide. Slide means a portion of CPU memory, hard disk resources. Maybe in that longest node, one CPU, maybe here I got, let's say, 4 gig RAM. You don't need to care about that. They will have the slide, okay, and then usage. So even if you've got one node, still we can have parallel process, all right? And together with a lot more technology, the key, the distribution that we discussed in data warehouse, in Redshift, you can join 100 node work together, okay, so that for petabyte transaction, they still can support and still can perform well. Okay, they perform well in a very large database, analytic database. Okay, so that's some more technical rather than this marketing slide. All right, so let's take a look on the data warehouse. Yeah, the data warehouse uh, in the early years, as I mentioned, because the Redshift alliance on 2013, 2014, 15, 16, a lot of people use Redshift to do the processing because Redshift the machine is so powerful, so many CPU. All right, we use SQL statement to do the transform, to do the process. Okay, but since 2017, we don't do it anymore because we have GRU. Okay, that's the sequence, the scenario. All right, so it's now more focused on storing the data. Okay, before we may consider this as a processing engine. Okay, so data warehouse and transactional database, as I mentioned, transactional database, traditional database, I should say traditional transactional database is focused on OLTP now, right? For those database, focus on a lot of update, okay, and concurrent access, okay. But by using this database, we can hardly make efficient conclusion related to analytic data. All right. So normally we need to transfer those transactional database from OLTP, transactional processing, to OLAP. Okay. So the data warehouse. The data warehouse, normally the table would be different. Here we likely see something fact table, dimension table. All right. So fact table store likely the numbers. All right, our sales quota, our delivery fee, tax. Okay, and then what are the dimension that related to our data? So we need to transform from here to there, and the perfect case is using GRU to do this transformation nowadays. Okay, so this is analytic. Okay, a lot of company try to focus on what product, what region, what time they are selling the better, so that they adjust their business, yeah, to save costs. And as I mentioned, I deliver to some Europe crime investigation department. They use this to reduce crime, try to reduce the crime. Okay, so not just business side. Okay, and then for this data warehouse, they are very different from traditional database. Traditional database, we talk about normalization, try to reduce the duplicated data. But data warehouse, we don't care. The most important thing is we might have many duplicated data, but the most important thing is when we run the query, okay, we want to have a fast result so that we can make decision faster. Okay, maybe we have really a lot of duplicated data. Okay, now Redshift, if you select the biggest instance type, 128 node, store the data inside Redshift at most nowadays is 8 petabyte. Okay, when I firstly teach many years before, only 2 petabyte. Okay, now support 8. But as I said before, you can offload some process the data. Okay, as we mentioned, Redshift, we store the process the data, right? Suppose you really got 10 petabyte, 500 petabyte. What can I do? Okay, you may offload some old data. Okay, 10 years before, 20 years before. Those results move back to S3. Okay, but we are not going to directly query from S3. Okay, your engine, your client still connect to Redshift, and that's what we call Spectrum. Okay, so that when you run those query, okay, this external table, AWS spin up some Spectrum machine. This is hidden, you cannot see. All right, so here they will get the data from S3. Just the latency is a little bit higher. All right, but you still can use the same SQL statement, query all those very old data. The key takeaway is that it is no longer this limit. You can have exabyte data, all right, and connect to one single point and run those query. Okay, because our data keep growing. All right, yeah, some old data move back to S3. That's the scenario. So we use data warehouse. First of all, your data can be from many different sources. That's why we need ETL. All right, you may have some data in Facebook, Twitter, from the world, all right? So we aggregate all those into a data warehouse. Data warehouse should be very structured, okay? So consistent. We focus on analyze historical data, not mainly on current, okay? Not just current, all right? And they spend a lot of effort to make your query still fast, even if you got petabyte, million, trillions, billions of data, okay? So this is Amazon Redshift, okay? So the definition is petabyte scale. And nowadays we call it exabyte because we can offload the data back to S3. Thank you, the Spectrum. But this is a data warehouse technology. Okay, every day we keep appending new data into Redshift. And then comparing with other database, the purpose is different. All right, RDS is focused on now transactional, and the maximum database size for most engine, as I said before, 16 terabyte. Okay, but Aurora we support 128 at the moment. Okay, and DynamoDB we say the database size could be unlimited, but most people just have a few hundred terabyte data, not exabyte. All right, and then Elasticache is in memory. Okay, you will not have terabyte data in memory, right? Okay, so Redshift is for very large analytic historical database. Okay, the position for this purpose-built database. So this is relational data warehouse, still relation. Okay, still very structured. But even now they support JSON, a little bit semi-structured, but originally still very structured data. Parallel processing. Okay, even if you got only one node, you still have two slides, still have parallel process, and that's why it runs faster than the progress in my example. All right, suppose you got 100 node, every node you got 8, 16 slides, you have thousands of slides parallel process your query at the same time. Okay, that's why so big the database, we still can respond efficiently. So it's fully managed. Okay, the data, where do we store? Actually, it's local disk, right? You got the Redshift node, all right? The data is stored locally. So that's why they are fast. We are not using any external storage because by using external storage, there is network, okay? Going to think about EBS. If you're using EC2, EC2 actually store in EBS. We all know that, right? EBS is a network storage. Okay, EFS is network storage. But for Redshift, we want it super fast. So we don't store in the external storage, just local disk. And those local disks could be hard disk, could be SSD. SSD is even faster. And once again, we have resilience. We don't have a single copy. Okay, your data is distributed across the node. Okay, and yeah, the cost is very low. All right, they will say for one terabyte data, around 1,000 a year. If you do the calculation, it's around one Starbucks coffee a day. Okay, and then you can run those database. Think about Oracle. You pay millions of dollars. All right. So for Redshift Spectrum, it means that some of your data, some of your processed data, your result load back to S3 so that it is exabyte scalable. And then you use the same method to access. Still, you just create another table. The data is located in S3. Okay, pay per query. All right, and then elastic scale, AWS manage. Okay, and then SQL, still SQL statement, nothing else. All right. So some use case here is that maybe you got online transactional processing, maybe in RDS, on-prem, or running on EC2, it doesn't matter. okay, so that we group all those data into Redshift. There are many methods that you can load data into Redshift. Even your data in EMR, we can load to Redshift. After EMR, you finish processing, load those data into Redshift. But the best way loading data into Redshift is using copy command. Okay, copy command, you cannot find this command in PostgreSQL. It is totally developed by AWS. Okay, copy command. So inside Redshift, say for example, the ODBC, JDBC client, you connect to the endpoint and run the command copy. You really use the copy command, likely from S3. Okay, and then copy those data into Redshift. Okay, what was the special? Because we can leverage parallel processing. Suppose you got 8 node, and then each node you got 4 slide. So you got 32 slide at total. And then you better specify your source file, 32 file in S3, and then parallel process, okay, instead of a single thread connection. Okay, so this is the best way loading data into Redshift. And every day we do similar. Okay, the number of files should be the same or a multiple number of your slide. All right, loading data into Redshift. And then at the end, you do the visualization. You use QuickSight, third-party tools, Tableau, Spotfire, Power BI, it doesn't matter. All right, so that's the scenario. And then keep sending abandoned data into the Redshift. Okay, comparing with other red local company, it is very low cost. Okay, a coffee a day. They say that. They ask us to say that. Okay, and then suppose your data in S3, maybe some semi-structured, unstructured data. We use EML because we can process unstructured data. Maybe after you process, the result is then structured, and then we load to Redshift. This is just another example. Yeah, and then we use SQL statement to query those log, transform. We now transform and reach using EML rather than do it in Redshift. Once again, 6, 7, 8 years before we say transform in Redshift. Don't do it now. Okay, do it in EML, do it in Glue. All right. So we can support copy. Once again, copy command, we leverage the parallel processing. And then from HDFS, say for example, the result back to Redshift. Okay, so that we focus on looking those historical data, the insight. I just heard Slack. Very good question. Is Redshift across ASET? The answer is no. Redshift and EML is single ASET. But let me double check because AWS got new features enhancement every day. Let me just double check in the FAQ before I answer you. Okay. Single AZ available. See whether I can find in seconds. If not, I take more time. Availability. Let me search soon. Okay. I may need some more time. I just see whether they got any new enhancement because I teach this class around 3 or 4 months before. Okay. Is transient Redshift custom industry practice? No. All right. Normally, Redshift, we store the historical data. We will keep the Redshift. We will not terminate the Redshift. Okay, normally. You get my point? Because if you take a look on the pipeline, Redshift is considered your result, store the data there. Okay, so we will not terminate Redshift in most cases. Okay, so Because EMR, we consider this is processing. Okay, so we will terminate after you finish the process. The most important is your data. Okay, here we saw the data. All right, so we will not terminate it unless you just test it. Okay, we will just keep it running. But how can we save some cost? Once again, we load back the data testing. We load back the data into S3, and then we don't need that much instance. We don't need that much storage, so that you can reduce the cost. But we will not terminate Redshift in most cases. Okay, so Redshift should be one single ASET, but I find it supporting a little bit later, maybe in the break. So Kinesis, this scenario is talking about that we can integrate with many other AWS services. We can, suppose you still have stream data and you want to store in Redshift, okay? You can enjoy the Kinesis. Remember, Firehose, we support the destination, not only S3, but Redshift, Elasticsearch, Splunk, Datadog. Redshift is one of the support destination inside Firehose. So you can integrate with Firehose and load data into Redshift. Okay, but the best method is copy from S3, parallel processing. Actually, if you stream the data from Firehose to Redshift, they will use a intermediate S3 bucket. Okay, technically, you stream to S3 and copy command to Redshift. All right, but you don't need to write the copy command. But under the cover, they still use S3. That's why you need to select an intermediate S3 bucket. Okay, because under the cover, they still use copy command. All right. So EMR and Redshift, this is very interesting. As I said, EMR start from 2009, Redshift 2013. So in the year of 2014, 15, 16, a lot of people, even AWS staff, do not know the position between these two. All right. Internally, we think we have some competition because both can be used to process the data, can store the data. You can store the data in Hadoop file system. You can store the data here. You can transform the data using SQL statement in Redshift. You can transform, of course, EMR, a lot of tools that we can use to transform Pig, Hive, Spark. So internally have a little bit competition. But since 2018, 19, then they are more clear. All right. EMR nowadays we will say focus on process the data. And then this is data warehouse. Your result you store here. Okay. Nowadays, don't process using a Redshift. Okay. You get many other tools to do the processing. Okay. It's much more clear nowadays. Okay. So they are totally different. As we talk a lot, EMR for processing the data, batch, stream, interactive, all right, transform. But Redshift, yeah, store those historical results and then ready to use SQL statement and ready for your visualization. Okay, store your data. Okay, and if you take a look on the comparison, actually they both use SQL statement, but they are totally different things. Okay, this is data warehouse. Okay, Hive, you can query the data. All right, you can make the data catalog. Okay, but Hive is not actually a database or data warehouse. All right, so they're totally different. Even their SQL statement. All right, you can use Hive to make the catalog, the query, ad hoc query. All right, but Redshift more on historical data. Okay, and then Postal. Once again, both SQL statement. What's the difference? This Postal, the data in memory. Redshift, the data in local disk, SSD. All right. Postal, normally you may have a gig, a few gig data, all right? Not even petabyte, okay? But Redshift, of course, we support exabyte, petabyte data, all right? Although we both use SQL statement, this is not data warehouse. Okay, this is not data warehouse. Okay, this is data warehouse. All right, so that's why in module 3 we talk about module 3 and 4. Use right tools for your big data. All right, if you have data warehouse, normally when you draw the diagram in many architecture, Redshift is at the end. Okay, just a little bit before the visualization. Okay, it's data warehouse. The data in local storage, you scale by adding more node, manage service so that you don't need to handle the update, the patching, the availability. Okay, by default, the Redshift data will be back up to S3 every day. Okay, but default they only keep for 1 day. You can extend to the automatic update to 35 day, or you can take many snapshot. If you take many snapshot, it will keep forever. It is not only the same for Redshift, but for other database. RDS, DynamoDB, Redshift, same. They have automatic update, but in a certain short period. Okay, Redshift just default 1 day. RDS default 7 day. They both can extend to 35 day. But after 35 day, the backup will be gone. All right. So you need manual backup to keep longer. But of course, manual backup, there is cost on that. And then columnar storage. Okay, so that we can write the query, analytic query much faster. Okay, one key point is for columnar storage, because analytic query, likely I want to find, say for example, in some table, here is the value, okay, the amount, okay, the dollar, all right, and then which country, which product you sell most. Instead of grab all the data and filter out, I just focus, get these two columns. All right, so less IO, much faster the query. Okay, columnar storage. Other database, RDS, they are row-based storage. Okay, they store the data like this, and then Redshift, they store the data vertically. Okay, and then yeah, metadata AWS, the Redshift self-manage. Okay, not using Hive, not using open source. You can use ODBC, JDBC, and nowadays we can use Redshift API. Okay, suppose some people ask a question on that before. You can have Python, Java, the API connecting not just traditional ODBC, JDBC kind. You can create group so that some user have some permission on some table, something like that. You can write user-defined function. Okay, this one we already discussed in module 5, ad hoc query. Okay, both you can run SQL statement. This one is more ad hoc. Okay, scaling automatically, totally serverless. Redshift is not serverless. Under the cover, still EC2, but you cannot touch those EC2. All right, and then the storage here in S3, the storage here in local, we support different types of format. And now Redshift also support JSON. Yeah, that's something that improved. Here they got the catalog. JDBC use IAM, and then in the middle EMR. Likely we scale by creating more node. AWS manage. You store the data in S3, HDFS, many framework. Okay, not just SQL statement. You can integrate together with Glue and use AD to be the authentication of the EMR. Okay. So Redshift architecture is that, as I said, you can create a lot of node. I just show you the look and feel of how to create a Redshift cluster. Yeah, once again, if you want to try, there is a free lab on QuickLab that actually create a Redshift cluster and then do some simple query, create table, something like that. So Redshift, if I go to Redshift and then create cluster, give a name and the type. Okay, it affects your pricing. Okay, the cheapest is the DC. DC means dense compute, more CPU resources. DS means more storage. Okay, they use hard disk to store the data. This one use SSD. But now AWS recommend you use RA3. Okay, a new technology, much better. If you want to provision 8 petabyte, you must use the RA3. But the pricing is different. Some of them relatively cheap, $0.3 an hour. Okay, but if you use this powerful machine, $13. Okay, 1 year you can buy a Ferrari. Okay, so take a look on the pricing. And then how many node do you want? Okay, suppose I want a very big giant cluster, then this guy, and then 100 node. Okay, of course, this could be very expensive. Okay, $1 million per month, 180 no. Okay, every month you can buy free Lamborghini. And then what are the password? I better move back. Okay, otherwise I will pay for that. Okay, so let me just show you. You can create one node cluster. Okay, but one node, yeah, you lose the load, then you lose all. Actually, they have backup. If you have only one node cluster and it fail, uh, you still have the data from backup. But normally the backup, there will be 5 minute RPO. You will lose 5 minutes data. Okay, many other database is similar. And then you can configure. You need to select which VPC and then which subnet. Okay, so it is ASAP time. All right. And then, yeah, some other configuration, maintenance, backup, default automatically keep for 1 day. You can keep for longer. At most, it's 35 days, but longer, yeah, additional cost. Okay, so after that, you can create a Redshift, and nowadays you can run the query here. Before you need some ODBC, JDBC client connect inside, and then you can do the configuration. If you want to try the free lab. Okay, so if you got only one node, there will not be master compute, just one node. Okay, everything there. But for a larger cluster, okay, similar to EMR, you can have the leader node and then the compute node. Okay, the leader node, you don't need to pay. It's free of charge. Okay, you just pay for the compute node, and only the compute node, the data will be stored there. Okay, you can have up to 128 compute nodes at the moment. All right, and then backup to S3 automatically. You can load data. So your client connect to ODBC, JDBC, but nowadays you can connect to the API endpoint. After you connect to ODBC, JDBC, suppose I want to query the data, you write a select statement. Okay, and here generate the executor pane and then distribute. You don't need to care about that. Redshift will care that thing. We'll distribute those query so that every node do a portion of the job and then get the result and then group together and send back to the master node and send back to you. Okay, you got your result, just like traditionally how you interact with the relational database. But actually, it's distributed processing. And between the node, by default, is 10 gig network. But I'm told that AWS is increasing the backbone of many services to 800 gig network. All right, but I think at the moment they still use 10 gig. Okay, but going to 800 gig super fast network. Okay, so nowadays we don't have just these two platforms. DC dense compute, more CPU. Okay, for transformation. DS more storage. Okay, you can have up to 2 petabyte. But now we say these two are legacy. Use the RA3. Okay, so we got faster hard disk, more newer technology. Okay, and then this is Redshift. By default, it is not encrypt. I mean, the data at rest, but data in transit is SSL encrypt. Okay, and then yeah, you can specify only accept SSL encryption traffic. And then you can specify, actually parameter group is just setting. Like by default, the date. Do you want year, month, date, or day, month, year? Okay, just a few settings. The default behavior, the settings inside, you can specify in the parameter group. The password, okay, when you launch the cluster, okay, you create a password. Don't One thing we need to keep in mind that by paying those database, we have the service level. For service level, who can create a cluster? Uh, who can modify those cluster? We need AWS IAM permission. All right. But inside the DB, all right, you can create the user. This is Redshift things. Okay, IAM just control service level. In database level, who can create table, insert, update, delete data. You grant permission inside Redshift. You create user, you grant right there. Okay, so this is also related to security best practice because it's actually uh, yeah, yeah, access control, right? We create EC2, we can have the data, store the data, encrypt. Yeah, S3, we also encrypt the data. One thing, keep in mind that S3, we can encrypt the data. Redshift, we can also encrypt the data, but those encryption is totally independent. Okay, even if your data in S3 not encrypt, when you copy into Redshift, you can have the data encrypt, or even if the data here encrypt, Redshift not encrypt, so it's independent, I would say. Okay, this encryption is totally independent from Redshift uh, uh, encryption. So case study, I would rather say something new rather than this is very old case study. Um, if you go to AWS case study, last year when I really teaching Redshift, uh, that class I have more than 20 students from different industry, and AWS they have two solution architect joined together to answer question every day. Yeah, so they asked me to talk about this case that time. All right, so I talk about that case. Uh, if you go to take a look on Redshift, you search Redshift, and then uh, last year, so I should go to 2020, right? They asked me to talk about NASDAQ. Okay, last year. Okay, as you can see, we all know what is NASDAQ. Okay, uh, right. They got 70. Where is 70? They asked me to talk about this number. 70 billion record every day. All right, every minute, all the stock. Okay, you got new data. They moved to Redshift, okay, in around 2000, start considering Redshift 2014 and 18, most moved to Redshift. If you are interested, you can take a look further. Okay, just AWS Hong Kong asked me to talk about that case. Okay, so yeah, I'm not going to use this. Just in many architecture, yeah, you got your source data, S3 data pipeline. Maybe you got some on-prem data. Okay, and then process using EMR, using container, using EC2, using machine learning, whatever. All right. So Redshift, they have some stage, and then actually at the end store the data, and then you visualize. Maybe you need some enrichment. All right. So normally in the architecture, it is a later part. Okay. So let's take a look on the answer. What function we can do in the leader load? Actually, you only can touch the leader load. I mean, using ODBC, JDBC, you cannot SSH to Redshift. Okay, you cannot touch the underlying OS. It's totally managed by AWS. It's different from EMR because EMR we are using Hadoop. AWS allow you to go inside to install something, but Redshift is totally AWS product. Okay, they just provide the endpoint for you to connect to consume the database. Okay, like RDS. Store the metadata, and then the leader node helps you to distribute the query. Okay, actually they don't have data inside the leader node, and it is free of charge for the leader node. Okay, if you are not using one node. Okay, if you use provision one node, of course you pay for that. Okay, and then some other service load data into Redshift, DynamoDB, EMR. Okay, yeah, yesterday we talked about EMR. We can load data into Redshift, pipeline if you are using on-prem, Firehose, but the best method, once again, S3 to load data into Redshift. And then, yeah, Redshift over EML, they are totally different product. Okay, Redshift for storing your structured data, but EML is for processing, okay, in the data pipeline. Okay, so do you have any questions? I will get some support to answer Jess' question. Anyone got any question related to Redshift, this topic? Uh, Although we don't have lab, once again, in QuickLab, there is a free lab you can do anytime later. Create the Redshift cluster. And in our lab 6, at the end, you will also touch a little bit on Redshift. Okay? So, any questions? Yeah, Darren, you are typing, right? Oh, EML. So what is your question? Sorry, what is your question? Yeah, EML workflow. Mhm. Um, okay. For others, if you don't have any question, let's take a break. Yeah, let me handle this question a little bit later. Um, let's come back 11:25. Okay, everybody. Yeah, 11:25. Let's come back this time. Okay. Darren, I don't quite get your question. What is your question? Doesn't matter. When we come back, we talk about it. Okay, finish the break. Everybody come back. Okay, thank you. Let's continue. Darren, your question is related to control the workflow of EML. Uh, uh, I data pipeline. Uh, Let me rephrase to have a better word related to data pipeline. For doing ETL, nowadays, we got a serverless service, Glue. Okay, if those are the support source and destination, maybe Glue could be a better choice. But data pipeline, we still use it in many cases, especially you got on-prem. Okay, uh, data pipeline launched in 2012, grew 2017. But if you have data in your on-prem environment, okay, it is a perfect case to use data pipeline. Even S3 launched in 2006, we still use it. So uh, for workflow, data pipeline actually control the data movement between your AWS compute storage service and on-prem. So in many cases, we still can use it. Uh, but why nowadays we recommend Glue first? Because it is serverless. All right. Serverless means you don't need to handle so much heavy lifting, the availability, scalability, something like that. So you offload even further. All right. So uh, for selecting any service, AWS got wide range of service. Sometimes they have a little bit overlap. The most important thing is that you can do your job successfully, happily. All right, no matter what tools you are going to use. If you are talking about workflow, okay, something that we didn't mention in this training is step function. Okay, uh, you can also integrate with step function. Okay, if you're talking about workflow, AWS got many documentation, many blog, many method, many solution. So you just find one suitable for your environment, your situation. I don't know whether you heard about step function a lot. When we talk about workflow, all right, in AWS. Let me search AWS step function. You can consider this as well. It's a workflow, but also serverless. All right. If you want me to find you a case related to EML, actually step function can do a lot of things. Most likely call Lambda function to do something automatically. Okay. Calling to the flow. Sometimes I want to run some tasks parallel. Sometimes I want to choose. Okay. Just like if then else, if not this and then that this sequential according to your order. So related to your topic, you can also consider this one. Let me post it into Slack. And if I go to this web page, then you can use step function. It's already 2 years to orchestrate EML workflow. We can also create the EML cluster. But the point of using step function is that this is serverless technology. Once again, offload your job, your task. But using data pipeline, you would see those EC2 instances living inside your AWS account. Okay, so you need to manage them. Okay, so that's a little bit different. Both could be used to achieve the same result, but we now suggest serverless technology. But Glue for ETL, okay, data pipeline can be used to ETL and also to orchestrate the workflow. Step function purely for workflow management. Okay, so uh, you just find one way that you are comfort to work with. Okay. Yeah, if uh, I will say this is really interesting. If you just focus on ETL, yeah, Glue is good. But sometimes we want EC2 because we want to install something inside. Suppose I got some security enhancement checking application. Security team must ask us to install that and do some scan. Glue, you cannot do that, right? For EC2, you can install something, do some customization. So I will not just say which one is preferred. I will say for that circumstance, that scenario, maybe this one is better. Okay, so there is consideration. You get my point, Darren? If you just have ETL, nothing else, grew. Okay, yeah, I hope you understand. Okay, so yeah, I also answered Jess's question. Jess, yeah, across ASAT, as you can see in, where is it? Here, Redshift still single ASAT. So it is possible that if one big earthquake, tsunami, typhoon, the ASAT can go down. All right. So if you really need to consider all this, you need to plan your data. Do we need to export, deliver to another region to increase the availability? This is what when we plan, when we do the architecture. All right. But your data, if you already back up in S3, it is already region bind. You got another copy in another ASAT. But if one ASAT goes down, I need to spin up another Redshift cluster in another ASAT. There will be some downtime. All right. But we need to plan for that. One key point is Redshift is ASAT bind. Okay. So module 13, let's keep going. Yeah, and let me talk maybe almost 1 hour more. Then we start the lab, start the lunch. Okay. So keep going. Module 13, once again, no lab in this module. Just talk about security. Security is the most important consideration using cloud. All right. Top priority. So yeah, let's take a look here. The whole pipeline, it is not in the middle of a stage. We need to be secure. Raw data, secure. Access control, and then also maybe encryption, data in transit, data at rest, and then ingress. Okay, when you store the data in those machine or even service. Okay, think about once again access control, security, and the availability. If you just have one copy and lose those copy, you lose your data. It also affects the security. Okay, so once again, if you use some managed service already, they have highly available, and then you can set some security on top. And then storage process everywhere. We need to consider security. A lot of company have security team to guideline so that our whole project, whole company can meet some standard, like ISO something, like a financial company, especially in Hong Kong, the bank need to meet some standard provided by HKMA, and then also some other country, I think they have similar things. Yeah, so security overview, one very important concept is that share responsibility, not just AWS do everything. Okay, as you can see, AWS handle all the data center, all the infrastructure, compute, storage, network, the hardware, the region availability zone, those security. Okay, no one can go to AWS data center and take a look on their virtual machine, their Hadoop cluster. No, all right, never can go inside those data center. They have some security guard protect, and I really still have some student ask me something question like this. How does AWS destroy the hard disk in on-prem environment? We have some standard. Actually, you don't need to care about that. Okay. The most important is that in on-prem, how you destroy the hard disk affect how you got compliance. Okay, or some standard. The most important is you can in the cloud environment still meet those compliance, those standard. AWS, you can refer a lot of document. Okay, go to compliance page, go to artifact page, how to help you meet those compliance. All right, you don't need to care about. Of course, AWS will destroy the hard disk. They got some standard so that to meet your compliance. And this diagram means that you still need to do a lot of things. Okay, suppose you are using EC2, using EMR, using Redshift, because all those live inside VPC. So you need to configure the virtual private cloud, the network, private route table. All right. And then the operating system, if you use EC2, you need to manage the update. But Redshift, you don't need to touch that because you cannot touch the OS. However, for EMR, you still can go inside to the OS. And then firewall, no matter use the VPC firewall, security group, network access control list, and then inside of Windows, Linux, you still can use firewall. Encryption, are we going to use client side? It means you encrypt first before you upload to the storage. And then use some server-side technology. Do it by S3, do it by EBS, do it by Redshift, etc. And then network traffic protection, encryption, access control, how you run right in the service level and how you run right inside the database storage level. Your application, you still need to protect. We are not going to open to the world, all right? Rather, I may just allow the internal application for internal IP address. We can use the bucket policy, the IAM policy, resources policy, and then your data, okay, how you consume. But one key message is that by using AWS, you offload really a lot of responsibility. So your security job should be easier. In on-prem, you need to do everything, okay? Physical control, hardware, all right? But now on AWS, you do less than before, okay? Easier than before. And if you use more managed service, let's say you use DynamoDB, DynamoDB doesn't live inside VPC. So you don't need to configure the network. If you use RDS, you cannot touch the OS. RDS, Redshift, DynamoDB, no OS at all. All right. So if you use more and more managed service or even serverless service, you shift more responsibility to AWS. So maybe you just say, for example, S3, a few checkbox, then you can do the security already. Okay. So in cloud should be easier, could be even more secure than on-prem. All right. In US, the government cloud, even US government, even NASA, okay, have their data stored inside AWS. In some other country, the bank, they also use AWS more than on-prem already. You can find it in case study. Okay, so that's the key concept. And security responsibility, the blue color here means you are going to config. You still need patching if you use EC2 or some thing need inside VPC. You may need network configuration, as I mentioned before. You still have, say for example, your password rotation, your access control. You still need to configure the security group. We are not going to open everything to the world. All right. Yeah, the OS level, the firewall, network config. But AWS already share really a lot of security. They will protect. Yeah, no one can go into their center. How they destroy, how they help you. The compliance, network intrusion detection, instance isolation. Some student ask me, I have a machine in my account. You have a machine in your account. Can we accidentally talk to each other? Across account, not I would say, even if those machine in the same account, all right, you need to pass a lot of condition in order to allow them talk to each other. All right, you have to go through security group, network access control lead. So another account, of course, much more protection. All right, and then you can use some dedicated instance. So AWS handle a lot of responsibility already. And if we are being DDoS, okay, a lot of attack our website, attack our backend infra. If those attack is layer 3 and 4 network, TCP, UDP, you already got protection. All right, you don't need to pay any extra. Okay, but however, if those are HTTP attack, you need to pay for web application firewall, for the application layer DDoS. All right, so I mean, when you just start using AWS, you got really a lot of protection already. Okay, even if some service is uh yeah yeah in the free tier even. So suppose you want to take a look on how we can increase our security, because this is top priority. You go to this link and there is many white paper resources. You can do penetration tests, but you need to follow the guideline. Okay, something that you can do, something that you cannot do. Follow this guideline, tutorial, something like that. For compliance, many companies need to meet ISO. For the health company, they need to meet the HIPAA. All right. For any company, you have online payment transaction, PCI DSS standard, and in Europe they need to meet the GDPR. In US they need to meet some other standard. So yeah, we have many guidelines. So you go to this page and then you can take a look what you are going to meet in specific country or even a region. So and then next we are going to talk about individual service. Okay, what we can do. Say for example, EMR. EMR live inside VPC. All right, virtual private cloud. I hope everybody know what is VPC in Technical Essential in prerequisites. You should already know this is the virtual networking. So are we going to put the EMR in the public subnet? Public subnet means you can visit the world easily, okay, through the NAT gateway actually, but the world can also visit you. All right, so you're just pasting some machine in the internet. All right, personally, we have some project that some of our client exist around 2 or 3 years before use the default VPC because they're not network guy, they're just a startup company. Actually, is my student. Okay, they start doing something in AWS, put the RDS into the public subnet, and then ask us to do some re-architect enhancement. Okay, save cost, performance, higher security. Many customer ask about this, and then we go inside and take a look and see that by enable the VPC flow log, okay, every hour there are some, maybe not human, maybe some robot try to go inside the database using admin. We can capture something like that. Root administrator try to gain access, just randomly try password by some program. Okay, so this is really not safe that we put it in public subnet. Really a lot of robot maybe doing something like that. So yeah, suppose you have on-prem, okay, and then how you are going to talk to each other. VPN, we got encryption, but it may be affect because this is internet. Maybe consider something like direct connect. So the key point here is that EMR live inside VPC. How can we enhance the security? The first thing we can do is we move it into private subnet. Okay, private subnet means maybe you still can go to the world by using NAT, but the world cannot find you. You just have private IP address, 10.0 something, 192.0 something. Okay, but in some scenario, we actually do not allow outbound traffic. Okay, think about the world cannot visit you. However, these are easy to instance, right? EMR. If you are being installed some Trojan host, okay, so this Trojan host program may initial the outbound connection, send some data outside. So in some other scenario, maybe the database, maybe some backend processing, we create another subnet so that there is no routing to the world. just stay inside. Okay. And people start asking this question. For those EC2, how can we do the update, the window, the Linux, all right, if we cannot go to internet? AWS got many managed service. You can say, for example, use System Manager, okay, using a private link, the VPC endpoint, push the update to those machine. Or maybe another better way is your machine create from AMI, Amazon Machine Image. We just update the AMI and then create the machine again. Okay, because EML, likely it is possible that we terminate the cluster when we are not running. Tomorrow, we got new update, update the AMI, update the template, and then build the image again, build the cluster again with the new image. All right, so in that case, you don't need to go to internet. Okay, there is no door to internet to be more secure. All right, so some company is already doing something like this. EML security, EML is based on AWS account. That's why every API call, no matter this is create a cluster, okay, terminate the cluster, and also resize, must be authenticated. All right. Yeah, that is authenticate. If you're using the SDK, using the command line, using the management console, all this will be done automatically. Okay. And then you can only talk to the master. Like yesterday, we built the SSH channel in order to take a look on the pretty phrase, the web interface. But the master, you still can SSH to the other node. For EML, you can do this. The Redshift, we got similar architecture. You can never SSH to the Redshift node. All right. So what you can do, suppose you need to SSH, you need to open the door. But this door, 22, are we going to open to the world? All right. Maybe I just allow our company IP. Or if you go back to this slide, suppose you need to configure this cluster. Maybe I have jump box, okay, so that I remote to here. Only allow company IP remote here and then jump inside, okay? Or if you got VPN, only VPN machine, the IP address I can touch. In that case, you don't need public subnet. All right, so think about how we can enhance the security, okay? As long as you open the door, the security team may have some concern, okay? And then for security, we got the master and the slave, means the core node, task node. Yeah, we got two different security group. All right. Let's say I only allow SSH in my master security group only to certain IP address, not to the world. All right. If you are in company, you can remote, but at home, the staff, same account, same password, cannot remote to those machines. So this is another enhancement. The slave here, because you may have core node, actually you have the data. All right. So do we allow SSH at all? Maybe I don't need to go inside to the slave. I just block all the SSH connection, even from master, okay, to enhance the security. But this is your choice. You control the security group. And fine-grained access control, because EMR is AWS service, you can control who can create a cluster. Maybe more important, who can destroy the cluster. We don't want something like this, an employee going to leave the company and then terminate everything. All right. So how can we protect access control? And then yeah, that we can do it in the policy. Okay. So by using the policy, actually we deny terminate. All right. Deny override everything, even if you are given the admin access. So here it's just controlling what you can do. I deny certain action. Okay, remove tag, and also everything. Actually, action is API call. Option, the condition is optional. All right. Development. Okay, then you can terminate. But other than that, testing environment, production environment, we cannot terminate. Okay, so this is some access control using the IAM policy. And tagging is important because we can use tag to give permission. to shut down the resources, to terminate those resources. And we can also use tag. Next module, we are talking about cost, how much this customer, how much this project spend within a single AWS account. Yeah, that's important tagging. IAM is basically permission, but remember this is service level. All right, what you can do to interact with your AWS account, who can create bucket, DynamoDB, VPC, EMR, and Redshift cluster. Okay, so by IAM, we have, let me just display everything first. We can have user. IAM, first of all, you specify policy. All right, policy actually is just like the JSON document, allow and deny what the user can do. So you can grant right to user, all right, and then you can grant right to group. But we recommend using group even if got only one user, because the user may leave the company, change to other team, so that if we grant right to the group, when there is some change, we don't need to set the permission, revoke the permission, grant permission again. Okay. Another thing is role. Role is super important. Okay. In our technical essentials architecting, we already discussed role is temporary credentials. Okay. So after you authenticate, you got a temporary access key, secure access key token that will be expired. All right. By using the same key by default for 1 hour, the key expire, so that if somebody steal the key after a certain period, he can no longer do anything inside your AWS account. User and group is fixed credentials. So role is absolutely important. Some use case of role is that suppose a user normally he or she do not have permission to create a EMR cluster, but now they need to do that. Okay, how can they do? I don't want to grant more permission after they finish the job and remove those permission. Maybe I create a role and allow this user to assume the role, and this role you have the permission to create the EMR cluster, so that when this user assume the role, okay, and then using this permission to create the EMR cluster, the Redshift cluster, whatever API call. So after that, he go back to his originally credentials, and then they cannot touch. So the permission, the elevation, all right, raise permission, and then cross account communication, service and service talk to each other. We also use the role. So this is important in the security. And then next here, user, as I mentioned, policy and user. Okay, grant right for fixed credentials. Suppose the admin daily go into the console and do things, grant permission to the role. Okay, rather than user. Create a user. All right, create the cluster. Also, we need the permission. Everything you did in your AWS account, you need permission. So we can grant using this policy. You can restrict in the condition area in an IAM policy. You can specify which IP address, which time, which device type. Could be very granular, fine gain access control. All right. Inside, you can allow and deny. Let's say we don't allow, we deny, terminate the whole cluster or any resources. So role for temporary credentials. Okay, this is a very important concept. For those who take examination, no matter which examination, you will be asked something like this: how you grant access between service, between AWS account, between the federation. Okay, then we use temporary credentials or role. All right, that will be expired. So EC2, suppose your EC2 do something saved in S3. It is exactly the same the case. EML, after you finish processing, save the result into S3, into Redshift, just like what we talk about. We need permission in order to do that. EML underlie we use EC2. So EC2, you can insert a role so that when we do the job, we set policy, the permission. We can issue the HTTP put post get command, interact with S3, and then we can also interact with Redshift, say for example. It's really important. Otherwise, you will see they don't have permission, fail to do so. Okay. Best practice for people, we can use MFA. All right. Of course, we better not using the root account. Okay. It means the root user, the email address of your AWS account, because this guy is too powerful. All right. So the root account, we should require MFA and then log it in somewhere else. All right. Daily operation, use IAM user. Just like in every single lab, you are using an IAM user, AWS student. All right. And then grant permission so that you cannot touch anything else. And then the MFA means we don't just allow username, password. We need some software or hardware token so that it guarantees that is public or fan, okay, to do all the API call. So don't use the root user. This is the IAM related to create AWS resources, create bucket, DynamoDB table, RDS instance, okay, something like that. But inside EMR, okay, what we can do, we can use Kerberos. Likely nowadays is Microsoft AD. Use AD instead of creating user inside. All right, we link with the LDAP Microsoft Active Directory. So we create a user here. We may have hundreds of data scientists. Okay, we maintain their password here so that they need to offend in order to go inside, work with your Spark, Hadoop, or any application program. So we can link with the LDAP Kerberos authentication. And then secure the data. Likely, big data, you can use the EMR as a lot of module talking about the EMR. Inside EMR, the local disk, the HDFS could be having the data at rest encryption. Okay, but this, we need to do it in bootstrap option. It means that when you launch the cluster, you need to specify. Okay, you cannot change after you launch the cluster. And then data in transit, it means that from source to EMR or to other supported storage, we better encrypt those data. And from EMR to S3, if you are using EMRFS, the data actually stored in S3, we can encrypt. S3, the data, we can enable client-side or server-side encryption. Okay, so no matter you use which program to process your data, also think about encryption, data at rest, data in transit encryption. But most of them are not on by default. Okay, especially the data at rest encryption. You need to enable it. For data at rest encryption, after you process the data and you store in S3, okay, we support the server-side encryption. Okay, we have client-side encryption. It means that you encrypt first or use the features provided by AWS, the server-side encryption. But by using server-side encryption, how you manage the key, okay, the key can come from S3 and come from KMS. What key you are going to use, it means that, or come from client side. Suppose you have on-prem SafeNet hardware device. I want to use my own key. Some company have this compliance standard. I cannot use any other key. The key to encrypt anything must provided by a hardware located in on-prem environment. So in that case, we use SSE-C. Okay, so we distribute a copy between EMR and S3. If those data are encrypted, you need to decrypt first. So for AWS, if you use this tool, they will do it automatically. all right, because all living inside AWS. But if you use client-side encryption, server-side encryption, but client key, then you need to provide the key every time you interact with those data. So we support, the EMR support encrypt data before store in S3. That's client-side encryption. Okay, your EMR to S3, this is client-side because the encryption not happen inside S3, but actually is encrypted by the EMR. We support something like that. So if you choose one encryption method, because nowadays, I would say 15, 20 years before, we may consider what data we should encrypt, all right, to increase the security. And now, thank you Intel, because they have very good technology, so that when we encrypt and decrypt the data, the performance effect is very low, maybe just below 3-5%. So nowadays, we may consider by default, we should encrypt everything. And then what data not important and not to encrypt. So this is just some consideration, depends on your security team. Your application maybe talk to S3, and then suppose I want to copy this data into Hadoop file system. Are we going to use server-side encryption, client-side encryption? If those data originally in S3 is encrypted, then here we might need to decrypt first. Okay, and then after you process the data, save back to S3, do we need to encrypt those data? And then in the middle, okay, if you are using still map reduce, a lot of intermediate results saved in the Hadoop file system, this data may also need to be encrypted based on your security standard. Okay, so we can fulfill, let's say, using all the technology here, you can use client-side encryption. Suppose your data originally on-prem, encrypt first, store in S3, or use server-side encryption. Okay, this is server-side encryption using client key, the key provided by AWS, or the KMS, and transfer the data. If you use internet, of course, HTTPS, direct connect. Remember, by default, direct connect, the data is not encrypted. You just have a very fast, stable link between AWS and your on-prem environment. Okay, here it's not encrypted. If you use a slow ball or the hardware device, okay, all the data inside will be encrypted. But some other customer will encrypt the data first and then put inside the slow ball. So two encryption, okay, two layer of encryption. If you use storage gateway, it means that when you put something in the, just like the backup folder, all right, and then move to S3, they are encrypted by default. Okay, so depends on what method that you are going to use. Okay, and then the shuffle data, we should, I should remove too many line here. Okay, so the shuffle data means the intermediate result. We could encrypt those data, and then the result we save in S3, we can use client-side encryption, means the EMR encrypt, store here, or you can use server-side encryption. Okay, once again, server-side encryption, you can use the key provided by S3, KMS, something like that. For client-side encryption, it means that the key is not from S3. You encrypt the data first before you store in S3. If you still have on-prem environment, normally you will have a hardware device. Not just hardware device, in marketplace, AWS marketplace. Let me just quickly go there. Okay, so if you go to AWS marketplace, and then you search for key management service, and then you can find really a lot. Okay, some of them not provided by AWS. To generate the encryption key, different page, okay, showing really a lot. Okay, I know that many people use SafeNet, some other use liquid something. I forgot the name. So different. You can use marketplace as well. So this could be a virtual appliance, generate a key, and then you provide a key for the EMR to encrypt, decrypt, and then before we store the data, use this client-side encryption, but use custom key. Okay, custom key means can be on-prem, can be marketplace, just not provide by AWS by default. Okay, so server-side encryption means encrypt together with inside the storage. By default, server-side encryption, most of the service do not enable by default. Okay, only one is Glacier. Okay, even if you do nothing in Glacier, all the data is encrypted by default. Okay, but other, you need to enable encryption. When you create a S3 bucket, upload the data, you need to specify encryption. Redshift also. Suppose you are using RDS also. EC2, EBS also. You need to check the box, encrypt, and what key you are going to use. Is it from KMS key or from other party? All right. So only Glacier is encrypted by default, but others you can enable encryption. Most of them is quite easy. Just check the box. So here is client-side encryption, means that the key is provided by customer, hardware device, virtual appliance, marketplace, something like that. And then you use this key to encrypt the data. And when you decrypt the data, you need to provide this key. All right. So normally, in this case, you have direct connect, VPN, so that every time you can provide those key for your encrypt and decryption. Server-side encryption, the key can be generated inside S3. I will say S3 is one of the earliest service provided by AWS. At that time, 2006, okay, a lot of need for encryption. But at that time, we don't have KMS. All right, that's why we still can use S3 to generate the key for you. But by using this, you don't have much control. All right, you cannot control, say for example, key rotation. Okay, some company say they need to rotate the key every year, every half year, 3 months. You cannot do that. You have totally no control. All right. The reason of using this key is that you don't need to care. You just check the box and then the data is encrypted. But some scenario we need to use, say for example, KMS, because KMS you can control the rotation and you can set key policy. Key policy. What is key policy? Means who can touch the key and what the key can do. Okay, normally the key can encrypt, decrypt, but in some company, I really saw something like that. They just allow encrypt the data and store, but never decrypt the data. Okay, in most cases, we will not decrypt, but in some scenario, they may do that. Okay, but they set it in the permission, just encrypt, just keep. Okay, so key policy means you can control who can touch the key, what they can do, what the key can do. But if you use S3 key, the key provided by S3, you cannot touch that. Okay, so KMS, you can control the rotation. Okay, to have higher security, because some security team do not allow you to use one single key to encrypt for 20 years. All right. So benefit of using KMS. KMS is very easy to use. You just check the box. Okay. EBS, when you create a volume, check the box, already encrypt. S3, check the box. Okay. And then some other DynamoDB, Firehose, a large service. You just check the box and then you can have the T encrypt, rotate policy. Very easy to use. That's the benefit of using the KMS key. And then for EMR, because once again, we got local disk, we got the HDFS. the data inside here, if you need encrypt, by default is not enable the encryption. Okay, if you want to encrypt those data inside HDFS, you need to do it with a bootstrap action. Create a cluster, you need to specify. You cannot change later on. I can tell you this is exactly one examination question, all right, asking about that. Okay, so yeah, that's the scenario. Okay, you need to do it at the beginning. And data in transit, once again, data sent to S3 in transit, yeah, we use SSL. All right. Actually, nowadays it's not really SSL, it's TLS, support higher encryption algorithm, but we used it to call it SSL. Technically, nowadays it's TLS 1.2 version. Okay, it's not SSL 2 or 3 version. They're all encryption algorithm. But anyway, but we used it to call it SSL. The data is encrypted by default for data in transit. Okay, not data at rest. And then if you use the Snowball, the hardware device, it is encrypted by default inside the box. And then direct connect between AWS and your on-prem. This one, it's not encrypted. It's just a private link. I really have some client need to encrypt this data as well. So from AWS, that's the VPC, and then on-prem, all right, here using direct connect, and then want to encrypt this as well. All right, it is possible to do so. Build a VPN on top of direct connect. Okay, but it limits the speed because VPN we support only 1.25 gig per second. Suppose your direct connect, if this is 1 gig, no problem. Okay, if this is 10 gig and you encrypt, then the speed will become 1.25 gig. And now AWS in many regions, in many locations, they are moving to 100 gig per second. Okay, so VPN will limit your speed, but enable encryption. Storage gateway, once again, from on-prem, synchronize those data to S3. The data in transit could be encrypted, data at rest stored in S3. That's the story of S3. You can still have the encryption. We have a relatively new service called Data Sync. Okay, a little bit similar with storage gateway. Both we need to have on-prem hypervisor like VMware. We only support VMware, Hyper-V, and KVM. We install a virtual machine inside those hypervisor, and then the destination, we move those data through the internet or direct connect to S3. But what's the difference? Data sync is relatively new. AWS suggests it is faster, okay, 10 times faster than open source other method. But it is task-based, all right? You can schedule every day, every 2 weeks sync. Storage gateway is continuously, all right? It is a backup solution. It looks like our machine save in some storage, okay, just like NAS, just like other storage, and it automatically synchronized to AWS. Okay, that's a little bit different. And then storage gateway, we only move data to S3. Data sync, we can move those data to EFS. Okay, in EFS, it could be shared to multiple EC2 instance. Okay, so it is faster. So this is related to backup technology. Moving on-prem data to the cloud. All right. So data in transit, Hadoop file system between node. Okay, because we are having distributed process. The data will maybe sent between node. This shuffle phase, likely we use Hadoop file system, so, plain text by default, but we can enable it, the encryption. This is a bootstrap option. You can refer the right paper how actually configure all those things. We can also support client-side encryption. It means that not provided by AWS. Go to marketplace, go to partner, find some solution. And then security related to Kinesis. For Kinesis, actually, yeah, we have the SSL endpoint. Actually, most of the service we talk to inside AWS is by default the SSL enable. All right, you talk to S3, you talk to DynamoDB, you talk to the Kinesis, talk to Redshift API. They are all SSL endpoint. All right, and then for availability, Kinesis, suppose you upload the data into the Firehose delivery stream or data stream, they actually have the data across the ASAT inside the region. So you don't need to be afraid one ASAT goes down because of any natural disaster. Okay, because those data is physically across ASAT, just like S3, DynamoDB, SQS, etc. All right. So when I show you 2 days before, when you upload those data, you need to specify partition key, so they go to different SHA if you have different SHA, and then data brought, and then you will receive the sequential number. The sequence number is actually identify those records inside a SHA. We use partition key to identify which SHA the data go to, and then sequential key, sequence number is identify the data inside a SHA. So yeah, the data is by default accessible 24 hours across ASAT. But if you want to keep longer, you need to pay more. Of course, the maximum is 7 days. Okay, some security consideration when you because we contain the data. All right, and then we can integrate with KMS so that use KMS to encrypt those data. All right. Best practice, IAM. We use IAM to control the access control. Who can reshare, who can write data into the stream, to the Firehose, who can consume. We need permission, authenticate before you can consume those data. Once again, the best method is using role, because maybe your Lambda function process the data. You can use the Lambda function, execute a role. If those are EC2, EMR, those EC2, you can apply instant role, okay, rather than a fixed key. Okay, we don't recommend hard code the access key, secure access key into a program. We use role because it is temporary. All right. After that time, the key is invalid, and then you need to be re-authenticate again. That's very important concept in AWS security. And then best practice, yeah, we for any admin action, okay, you create more SHA, delete the delivery stream. We need to be public offend, and then once again, the data could be encrypted before when we store the data. Okay, DynamoDB security. Yeah, for DynamoDB security, once again, DynamoDB is a fully managed serverless technology. Okay, so we don't have any OS. We just control the access method by using like the IAM policy. Okay, still IAM policy. You can control who can make the API call. As long as this is IAM policy, we can grant to user group this is fixed credentials or role. Okay, we can have fine-grained access control. Who can create the DynamoDB table? Who can touch which attributes? Okay, or which item? Okay, very granular. And then link with the web identity. Like we need to have a Facebook account, Twitter, Amazon, Google, Yahoo, in order to authenticate and then grant you the token. Okay, so this is fine-grained access control. You can grant whole table or just individual attributes or individual item. All right, maybe some user cannot take a look on the credit card number, but they can take a look on the telephone number in order to call those customer. All right, so you can have fine-grained access control in DynamoDB. They are all using IAM policy. All right. So this is just an example. Inside IAM policy, normally the security team, security guy write and control this, not the developer. All right. We allow, these are all the API call action. You can get item, you can query, you can put item, you can delete item. And then not all the table, we use resources, only this table. And this is what we call ARN, Amazon Resources Name. Almost 100% here we talk about AWS. But Amazon don't just have AWS. They have more than 40 subsidiary. And in AWS, which service? This is DynamoDB. And then which region? Which account number? All right. Maybe because inside your account, you have table 1 in Singapore and Tokyo. All right. So we specify which region. This ARN is for us to identify which resources inside Amazon or inside AWS. So which table, and then condition is optional. Okay. You can ignore the condition. I mean, you don't necessarily write condition, but by using condition, you can say something like this: which IP address, which device type, which specific area you can touch. Say for example here, you can only touch this game ID, user ID, win and loss, but not others. Okay, so you can have further control. So that's very powerful control to your statement. Okay, so just another example, allow DynamoDB query update, but here we don't have delete. Okay, maybe the user, maybe the application can only consume, but not object level delete the whole table or data. All right, so maybe here we just can touch user ID and pop score rather than just like before, so many attributes that you can touch. Okay, so this is just an example. Here, the key concept is that we can have fine-grained access control on DynamoDB using IAM policy. And then web identity means suppose the user need to interact with the DynamoDB table, user or application or whatever need to be proper offend. As nowadays, many application, suppose you want to book some hotel staycation, and those application can link with Facebook, Google, Twitter, Yahoo. All right. So this is what we call web identity federation. What we do in AWS is actually we have a role and then set the policy. And then suppose you offend, and then you get the token, and the role allows you to assume based on policy, you can touch those resources, not just DynamoDB table, can be anything inside AWS, maybe S3, maybe some other Redshift service. So this is what we call web identity. The key reason of using that, we don't need to create the IAM user. All right. If you got only 5 admin, you create the IAM user. Suppose you got 100 admin, okay, maybe we better link to somewhere. If the application is facing public, okay, you may have millions of users going to your application. Okay, they may also get data from DynamoDB, right? So in this case, we use those federation, okay, rather than create a million user account. So access to DynamoDB, yeah, of course, no matter you use console, command line, API call, you need to be public offend, okay, no matter which service you touch, all right? That's security control. And then data protection. DynamoDB nowadays, we support server-side encryption, okay? When I firstly teach many years before, we don't have server-side encryption. And a lot of companies like to use DynamoDB. They have no choice to use client-side encryption. But now, not only data in transit, but at rest, we can use KMS nowadays. Okay, suppose anything fail, we can have point-in-time recovery. It means that load from backup, load the data from backup. Okay, but DynamoDB, we now support global table. It means that in Hong Kong, say for example, I got a whole copy. If you enable the global table, let's say I add Singapore, all right, this is Hong Kong. Okay, you have two set of data. All right, even if Hong Kong anything goes wrong, all the region goes down, you still have a complete copy. Okay, that's called global table. However, even if you got two region having the whole database, whole data set, if somebody did something wrong, all right, delete a record, very important. It will replicate this delete to another copy. So you lose your data. So in that case, you may need to restore from backup. All right, point in time recovery. You can restore normally up to 5 minutes before uh, uh, 5 minutes before you have any failure or did something wrong. So DynamoDB, yeah, you still can meet many compliance for health company, ISO, uh, PCI, all right, yeah, SOC in America, GPDR, all right. So help us to meet those compliance. Monitoring is important. We can take a look any abnormal API call. AWS, we have a lot of service. Say for example, one is called Guard Duty. It is a intrusion detection service. So suppose normally you build your EMR cluster Redshift in Singapore, suddenly, all right, in London, you spin up a whole cluster. Okay, for the past 2 3 years, you didn't touch anything in London. So we can find Guard Duty can find something like this, anything abnormal, all right, any API call abnormal, and then you can specify notification so that we know. You can also specify some action. All right. So monitoring is important to find anything abnormal, and also performance cost. Do I forgot to terminate the EMR instance so that I still pay for that? So without monitoring, you don't know you are overutilized, underutilized any abnormal pattern. Okay, a few more slides, and then we will have the lunch break together with the lab. Redshift security. Redshift live inside VPC. So we can put it in private subnet. We can have the SSL encryption. We can have the data encrypt using KMS or using other third-party key generation. Because our data, likely historical data, saved in Redshift, then compliance is also very important. And once again, Redshift, we support very high compliance so that many companies around the world need to meet those compliance. You can use network isolate. Suppose you are still using on-prem environment, and then you will have the VPC and then Redshift. You can create only private subnet and then use VPN Direct Connect, extend your on-prem data warehouse to AWS. So in this case, we are not opening our VPC to the world. We don't have public subnet. We don't have in NAT gateway. So that's kind of network isolation. It is super secure because no door to the world. And then you can use security group, block, I should say, allow only which IP, which port connecting to the Redshift cluster. And then you can use fixed IP. Dedicated tenants means you don't want to share with any other AWS customer the underlying architecture. So just like what I said, put your Redshift into private subnet. See whether you need some public instance. If you have some public facing app, maybe you still need public. But as I said, if you don't have public facing app, then you may just put everything private and then on-prem talk to those Redshift cluster. Redshift, we also support data at rest encryption. Okay, but yeah, we support KMS, we support Cloud HSM. Yeah, here you can, but it's not enabled by default. That's what I want to say. You need to create those and then rotate set permission. All right. Another security features is called Security Hub. It is just a centralized page. Okay, before we need to go to different console for different security purpose. Like I said, guard duty for network intrusion detection. Go to Macie. Macie can detect your S3 account, see anything open to the world, and then having some security information. Do we have telephone number? Do we have credit card? Do we have the let's say email address open in some open public bucket? All right. So we go to we have web application firewall. Now we have network firewall. We need to go to different console. Okay, but Security Hub is a central location so that you can configure and take a look on all the security. This is very good page for security team to work with. And then monitoring, logging your application log, your CloudTrail log to make the API call. We can have some evidence. Okay, suppose some employee really before they leave the company do something wrong, we have all those logging. Okay, and then a few last page. Yeah, here we take a look on some review. S3 support both client-side and server-side encryption. The answer is yes. You can encrypt the data first before you load to S3. And then you can also use the encryption provided by S3, S3 encryption, KMS encryption. And then why should you use root account in extreme case? I will say the root account, we mentioned we can use IAM policy, but the IAM policy will not apply to root user. Okay, even if you write deny everything, it will apply to only IAM user, group, and role. All right, so the root account, root user is extremely powerful. So do not use it in most cases. All right, and then by default, the data in HDFS is encrypted. No, most storage, the data is not encrypted by default when they store. Only Glacier. All right, EC2, actually the EMR using EC2, DynamoDB, Redshift, RDS, they are all not encrypted by default when we store the data. Only Glacier. Okay. So two more questions. How you're going to control the Kinesis resources? You can use IAM, and then for Firehose you can use the encryption as well. All right, set permission, and then yeah, you must lock down Redshift cluster. The answer is no. You can provision the Redshift cluster in public subnet, and everybody in the world touch that. Okay, it is possible to do so, but not recommend to do so. Okay, so yeah, very long module for this security. Is there any question before we go to the lunch break? Yeah, in this case, yeah, we finished module 13. Let's have 1 hour lunch and 45 minutes lab. So what will be the time then? Is it now is 1:35? Should be 2:20, right? Is it correct? So 1 hour, 1 hour lunch. Again, 1 hour lunch, and then 45 minutes. This is lab 6 Spark. Okay. Now is 1:35. So we come back to, is it 2:20? Am I correct? Yeah, should be 2:20. Okay, and we keep talking the next module. We still have two free module, actually two. Okay. Is that okay, everybody? Okay. Yeah. Please go to have lunch and then do the lab. Yeah. Afternoon, we are going to complete the class. Yeah, you will get your attendance sheet. Make sure Ted is registered in the class. Thank you. Okay, good afternoon, everybody. Uh, it is now 2:20. I just want to ask, have you finished lab 6? Is there any people still doing need a little bit more time? Anyone? Yeah, Darren finished. How about the others? We can start now, right? Okay, then let's start. Let's take a look on the agenda. Uh, if you take a look on this agenda, day 3 today, we finish module. We just talk about Redshift. We also talk about security right before we have lunch break. We got, it looks like we got 3 more module to go. But module 6 is just a few slide. Okay, some architecture suggest example. So not much content. 5 minutes, 10 minutes, we should be able to finish module 16. And then, so technically we got 2 more module. Uh, each module take around half an hour or a little bit more than half an hour. Course and visualization. Visualization is also relatively short, but we got another 45 minutes left. So after, I will just finish all the talking, 14, 15, 16, and 17 is just 2 or 3 slide wrap up. All right, just review what we learned, what are the key content, and then we will complete the class, show you how to get the attendance cert, and you also need to do something. But uh, yeah, one thing personally, I suggest whether we can do is that here, after every class, if you're interested, it is totally optional. Uh, I normally will take a photo with student and then post into the Slack group. Uh, Many years before, this is some physical training. Okay, I'm in the middle, and then really a lot of some of them is yeah, a wide range of different industry, and then yeah, nowadays because of the pandemic, and you can see I've got a lot of photo like this. Okay, because of the pandemic, we take the photo using yeah, this virtual platform. Okay, tools. So if you're interested, then we can switch on the camera and then uh, take a photo. Uh, you got 1 hour, a little bit more than 1 hour to prepare. Uh, if your computer do not have camera, your company computer, you can use the phone to join, but it's optional. Some of the students, they don't want to have the face show. It's okay, it's perfectly fine. I actually teach some US and UK company, all of the people, because they're quite sensitive, they don't allow showing the screen, yeah, the face to the world, especially the crime investigation department. So it doesn't matter. All right. So if you're interested, we can do something like this, but it's optional. Okay, let's keep going. Module 14. Okay, with related to course. Course is definitely important. Uh, yeah, first of all, let me talk a little bit on uh, the course concept on using AWS Cloud, not just big data, not just EML. Uh, Actually, by using any AWS service, there is 3 dimensions related to course. The first dimension is always storage. All right, let me just use this example. You have the data in S3, okay, the storage, you need to pay for that. But S3, we got the different tier, standard tier, Glacier, IA, the price is a little bit different. Okay, and if you use EC2, the EBS is also your storage. Say for example, DynamoDB, okay, storage. you also need to DynamoDB. We have storage on that. RDS, we have storage. Redshift, actually you provision the cluster, you still need to pay. Yeah, actually you pay. You include the storage, okay, when you pay for the Redshift cluster. So storage is one big dimension. The other dimension is data transfer. Don't forget this money, all right? Some project, forget about this. Data transfer, normally, uh, uh, here we talk in the whole, when we transfer out, okay, especially leave AWS, we have the charge on internet. Okay, take a look on the pricing. In US, it's 9 cents per gig. Okay, out to internet, it's 9 cents per gig. But in Hong Kong, in Singapore, it's a little bit more expensive. It's 12 cents per gig data. If you got 100 gig data sent out every day, that amount is not small. Okay, every day you got those data transfer out. And then not just internet, if you transfer out to another region, you also need to pay for that. Okay, but the amount is much lower. Okay, you can always go back and check the pricing. Let's say in US, this is 9 cents per gig. Region is 2 cents per gig. Okay, if you use Direct Connect, it consider similar spending like the region. Okay, but data transfer in, you don't need to pay for that. It's free of charge. So think about every day I got on-prem data upload to AWS. You don't need to pay for data transfer for that. Okay, transfer in is free. Transfer out, there is charge. Internet is more expensive. Depends on region. And then between ASAT, there is also pause on that. It's 1 cent per gig. This is between availability zone. Okay, no matter which service you are using. Suppose your EC2 one ASAC talk to another ASAC, talk the EC2 in one ASAC, DynamoDB, DynamoDB is not in VPC. Another example, EMR cluster. Okay, let's say we draw something like this. The ASAT, the EC2 is here, and then the EMR is here. Okay, because it's ASAT bind or Redshift cluster. Okay, cross ASAC communication, there is 1 cent per gig data transfer on that. Okay, so don't forget this amount. And then the last one is actually what we call service fee. That different service, the dimension is a little bit different. For S3, actually, it's just like put the data, get the data. Even if you issue list, you still need to pay for that. But the amount is very low and depends on the tier. If you're using infrequent access, the service fee is more expensive than that in standard tier. All right, check the pricing. And for EC2, actually, it's the uptime. When you turn off, shut down the instance, you don't need to pay for the service fee, the EC2, but you still need to pay for the storage. Okay, DynamoDB, they calculate on read write capacity unit. Okay, the throughput that you consume. Okay, because DynamoDB, we don't have, we are not a server, not like EC2, we can shut down. It is serverless technology, so they charge based on the capacity unit. Many serverless technology charge like this. Okay, for Lambda function, similar, but another function you don't have storage. You just pay for data transfer, and you also pay for the compute resources together with how much time you run those services. It's similar. So we got 3 dimensions. We understand the cost so that we can do some cost optimization. All right. So let's go inside, take a look on this module. This module, we focus everything on cost. Okay. Cost consideration, pricing model. Sometimes we just change a little bit pricing model, then you can save a lot. All right. But we need to understand the cost for different service. It is very transparent that every single service you can track the pricing easily. Okay, so this is not in a specific stage, but the whole data pipeline, we focus also on the cost. A good architecture, well architecture, should have the cost optimized. So first of all, we take a look on EMR. All right. Of course, we need to pay for EC2 based on the uptime. For EMR, it is a little bit more. You pay EC2 and a little bit more. That's why, because AWS already help you install the cluster, do the configuration, install all those applications. Once again, if you want to check the price, okay, let me get back my Google Chrome. Okay, here, you just search any service, AWS EMR pricing, and then EMR pricing. Of course, if each region would be a little bit different. Okay, suppose, let's say Hong Kong, Singapore, and then the EC2 pricing, let's say suppose you select M5 X large. Okay, totally, you pay for these two together. Okay, 0.2 for the M5 X large, and then you also need to pay for the EMR. A percentage, just like this, around 20% on top of your EC2 instance. As you can see, most of them maybe 20, 15%. All right, so you pay all together. All right, so this is the EMR together with the EC2. You can track the pricing. It's so transparent. And then, yeah, it apply on master node, core node, and task node. All right, but what we can do to save cost, if you select on demand, of course, it is relatively expensive. You can sign contract, commit 1 year, 3 year, reserve instance. And nowadays, we can use the saving plan instead of select which region, which instance type, you just commit on how much you are going to spend. Saving plan is something like this. I just commit every hour I spend $20 US. You don't need to care which region, which instance type. Okay, because I may change instance type. So saving plan nowadays, we quite more flexible rather than using the not so flexible reserved instance. Okay, but you can also use the spot instance. And then S3, RDS, DynamoDB, once again, storage. RDS, yeah, you also need to pay for the storage. Okay, so data transfer out, as I mentioned, there is a cost. Transfer out to internet, to another region, to another asset, there is also cost. Yeah, we need to take care. So for EML pricing, what I did is just go to the EML. You can take a look. This is very old, M3, M4. Now we have M6. Take a look on their pricing. Normally, when I teach architecting, I will show students this page. You may already go there before, but anyway, I just post once again. This is a very good page to summarize. It is very updated, not just EC2, but also RDS. Let's say I select Singapore this time, and then you can sort by instance type, you can sort by the price, on demand Linux, reserve 1 year, 3 year, full upfront, partial upfront. So you can select and you can take a look, compare the price, okay, for different region. Okay, this is very good page for you to have some comparison between instance type. Okay, but of course we also need to pay for EMR. All right, that page I just share, just focus on EC2. All right, in AWS we don't care. As you can see here, 10 node, 10 hour, or 100 node, 1 hour is the same. Okay, so we don't care how much time. Yeah, you think about, do we need more node, less time? or do it longer with less load. This is your choice. Okay. So think about we recommend to use transient customer. Means after you finish the job, then you terminate. I talked through this whole 3 day. All right. Yeah, because 9 to 5, 9 a.m. to 5 p.m. Processing. Okay, here 8 hours. So it means that you can save the money for the remaining 16 hours. Okay, next morning, 9:01, 9 or 8:95. Okay, 8:59. Start provision another customer. So just terminate if you can. All right, non-running, you are paying every single second for the whole day. Okay, so can we use transient customer to reduce the cost? Our data is already in some other service. If you can do this, you can save further. All right. Use auto scaling. It means that scale out more kernel and task node when necessary. And auto scaling, not just scale out. The icon is something like this: two arrow going out, two arrow going in. It means that we can scale out if we need those compute resources, and then scale in to save cost in low season, low period, nighttime. All right, so scale out and in so that you don't pay for idle resources. So EC2, as we mentioned before, we have on-demand, reserve, sport. Now we have saving pane. For saving pane, it is much more flexible. No need to select which region, no need to select which instance type. Okay, but when using sport, we can save up to around 80, 90%, 90% off. But the resources is not guaranteed. You bid for that. In EMR, it is perfectly fine. Maybe unless you want to analyze the real-time data. If I want to analyze the past data, like last quarter, okay, 1 or 2 days later, it doesn't matter. All right, and in this case, you can use spot instance. So by using spot instance, good for testing, yeah, good for some EMR job. All right, transform, do the using peak. Okay, I can do it 2 hours later. Okay, 12 hours later, 2 days later, if the price go down. So this is your choice. Yeah, using those spot instance. Okay, and if you don't need those instance, turn it off. All right, just don't keep it running. So RI is a reserve instance that you sign contract 1 year, 3 year. Suppose you just need those resources for half year. What can you do? Actually, you can go to marketplace to see anybody sell their existing contract. You can also do something like that. Okay, instead of a whole contract, we can sell our contract to other party, or you can buy some contract. Suppose they got 1.5 year, half year. All right. So it is possible to do so. All right. And then yeah, marketplace to see, yeah, as what I mentioned, sell your contract, buy your contract. No matter you sell or not, the one who take over the contract still got AWS support, still is a valid AWS customer. Okay, so think about this pricing option. Maybe default you use on demand. After you use this, I can show you in the page. Let me go back to my Google Chrome. Yeah, let's say M6 large instance. Let me just pick one. Yeah, too many instance type now. Okay, just for example like this, just the first one. If you don't sign contract, Linux machine, around 4 cents, 5 cents per hour. Okay, if you sign contract 1 year, okay, around 30% discount. If you sign contract with 3 year, okay, more than half. Okay, so if you take over some other party 1.5, 2 year contract, you can enjoy this price. Okay, just change the model. You have your budget, your cost lower by 58, 60%. All right. So just change the price model. If you can use the bid price, do it well. I really see some project that we work with. Uh, they spend millions Hong Kong dollar, all right, not US dollar, every month to AWS by using spot instance together with other approach, save 20 something percent. It means 200 more than $200,000 a month. Okay, it can really save a lot of money. All right, how can we do that? Of course, we can use everything from spot. However, we can use a banded approach that we may sign contract. Okay, suppose every month, sometimes you use 600 hour, 500 hour, 800 hour. You may sign something like this, 400 hour. All right, and then not enough, then you add together with the on-demand spot. All right, you don't necessarily use everything from spot, everything from on-demand. Okay, so you can mix together. That's why we can save some. And yeah, that's a spot instance. In Technical Essential class, we discussed what is spot instance. Just like the stock trading market, you set a bid price, but you pay for the spot price. Okay, so if the spot price is like this, and then you set a bid price, you are paying the spot price. But if you are outbid, okay, your resources will be terminated. I actually see some customer, they set the spot price as the on-demand price. All right, so they are paying just the spot price. Okay, but most of the case they will not be terminated because normally if you can run, say for example, $3 for that instant type, no one will use $4, right? Okay, you can yeah, because on demand is just $3. All right, so normally the spot instance, the market price, the bid price will not go over on demand, but it is not guaranteed. If you take a look on Christmas and November, the Thanksgiving, sometimes they go very close, even a little bit higher. But you need to keep monitor those spot instances if your job cannot fail. All right. But if your job, you could fail your job, you can do it later. It doesn't matter. Okay. So now we got something called spot block means 6 hour. So you can keep the instance running for 6 hour. All right. But you need to check, focus on the price because by default, the spot instance, the price change around every hour. But maybe I got a long running job inside EMR, run for 3, 4, 5 hours. Then spot block is good for you. Okay. So yeah, when can we use a spot? Normally, we don't recommend to use spot on master, okay, unless testing environment, all right, that you can have all the resources terminate. Master, we think about on demand or reserve or saving plan. Actually, saving plan, you just commit the money that you are going to pay can be shared between all the nodes. But task node, actually, we don't have HDFS, we don't have data there. All right, we just have compute resources. So it is a very good candidate to use spot instance. Okay, and you can actually see some report, say for example, certain instance type for the past 3 months, how many percentage really being terminated? Normally, it's less than 5%. Less than 5% of the people use spot instant really got terminated. Okay, especially recently years, because when I firstly teach AWS, I think only around 11 or 12 region. They don't, many region, just to AZ, they don't have that much resources. Nowadays, we got more than 20 region, and then we have, AWS have already a lot of compute resources. Yeah, now I can show you something related to bid price. Yeah, let me go inside to my console. Go to EC2, go to the spot request, and then pricing history. I just select randomly something. Let's say i3. I like i3 because the IOPS is super powerful. All right. And then for the past 3 months, okay, as you can see, the, the bid price didn't change at all. All right. Let's say this one. Yeah. This is in Hong Kong. So if you bid for 1.1 $1 even, okay, you are paying only 98 cents, okay, every single month. Let me select something because in Hong Kong, maybe we have really huge amount of resources and the demand supply is totally based on demand supply. I think Singapore, we can see something, yeah, like this. So in Singapore, as you can see, the price changed a little bit. So if in this time you bid for $1, you will be outbid, okay, and then your resources will be terminated. But if you bid for 1.5, you can run for 3 months without being terminated. You pay for this amount, okay. If you take a look and sign contract, you still need to pay around $2, okay. So you may save really a lot by using spot instance. And then if your cluster could fail, the core node, you can also use spot instance. But remember, once again, if you do something like this, do not save data inside the Hadoop file system. Okay, if you already saved to somewhere else, S3 and the DynamoDB, Redshift, it doesn't matter. Okay, I just lose my compute resources. I do this task, I do this job tomorrow. Okay, a few hours later. Okay, then yeah. So long-running cluster, you can have long-running cluster, maybe inside the Hadoop cluster, continuously. Many teams, many members keep sending job. I must have the data. Or another example is you really store data inside HDFS. I cannot uh, have the cluster fail. So in this case, maybe you cannot use spot instance. It depends. All right, depends on whether you have data here. All right. So think about the cost. You can really save a lot by using spot instance. Okay. Say some company, if you go to case study, you can find save 80, 90% of the budget. Okay. Think about 1 million become less than 200,000. All right. But yeah, the entire cluster could use spot instance, but your outbid, everything good. Okay. So by using spot instance, yeah, the data in HDFS will be lost, as I mentioned. Okay. Yeah, think about that. Test. If you are outbid, your instance will be terminated. You will got a notification 2 minutes. All right. So suppose now you outbid, you have 2 minutes. This 2 minutes is not for human. Okay. Is for you. Suppose you got this notification, the EMR, and then we need to stop, we need to save, we need to move, whatever. All right, is for your application. So we need to handle whether our application, our project can handle this. Okay, we keep running. Suddenly, all right, there is a notification that your cluster being terminated, your EC2 being terminated. All right, then yeah, we need to try, see whether your application can handle that. If you take a look on some case study, AlphaSense, they really save a lot by using spot instance. Okay, you can go to AWS case study. As you can see, from 5,000 to 80, really a lot, more than 90%. Okay, save 40,000 a year. You can take a look how they bid, they use. So once again, banded approach, we don't need to necessarily use the all the on demand, all the RI. You can use all together. Okay, suppose average I have this loading, then I use RI. And then after that, I use some on demand, use some sport to save costs. So in this case, by comparing with totally on demand, maybe you save more than 50% already just for this project. Okay, bandit approach, on demand together with RI, together with sport. Okay, use the simple calculator. Now we use price calculator. It's a newer version. Okay, use price calculator instead. So that yeah, if your loading is spiky, you can do it anytime, next hour, next week, next month. Then it is a very good approach. Okay, so next, as we mentioned, the storage, we need to pay for that no matter which service you use. Likely, S3, different region, the price is different. Normally, AWS will not increase price on any service and features. They will just reduce the price because as long as their AZ data center become bigger and bigger, their cost will become lower and lower, economic of scale. And then they will reduce the price. From day one, S3, 2006 to today, they reduced the price for around 8 to 10 times. Okay, really huge deduction. But every region, the price is a little bit different. US, normally the cost is lower, so it's cheaper comparing with Hong Kong, Singapore, and other region. Okay, so you need to pay for storage and service fee. I say service fee request. Okay, put, get. Once again, you can go to take a look on S3 pricing, S3 pricing, to take a look on the most updated pricing related to cost. Let's say Virginia, as you can see, 2 cents per gig, okay, 0.023. If you take a look on Singapore, 0.025. All right, a little bit more expensive. And then request, get, put, you need to pay for that. But every 1,000 requests, you pay for, I don't know how to say this number, 0.0004. All right, you can just calculate. A million, you pay maybe 40 cents or $4. You really need to do the calculation. It should be 40 cents. A million get, not a million file, 40 cents. Okay, so do some calculation. And then data transfer, as I mentioned, yeah, in Singapore is 0.09, and then some other region may be more expensive. Okay, so take a look on the pricing. Okay, so data transfer in is free. Infrequent access, normally infrequent access, it means that you should not keep download and upload there. Okay, so the difference between infrequent and Glacier is that Glacier, we do not support immediate access. Okay, from Glacier, you need to wait. Okay, traditionally, wait for 3 to 5 hours. But now you can pay for retrieval time. If you don't mind paying much more expensive, you can get the data much faster. But still, you need to wait every minute. Okay, so if you go back to this pricing, retrieve Glacier, yeah, here. Okay, traditionally, we just have standard retrieval, all right, 0.06, I think it's per gig. Take a look on every, and if you take a look here, explicit, okay, you can see it's much more expensive, 0.06 comparing with $12. Okay, you can pay for retrieval time. By using this, then you can get your object from Glacier around 5 minutes, but still not immediate access. All right. If you want to have a lower storage price, but still want immediate access, then infrequent access. All right. So that's related to S3. Take a look on their pricing. And then Glacier, sorry, this is Kinesis. Kinesis, we have data stream, also Firehose Analytic. Okay, you pay for all of them if you use all, pay as you grow. So we need to pay for SHA hour. Okay, actually three things. SHA hour, put, okay, it means you upload those data to the Kinesis data stream, and then extend data retention. By default, retain for 24 hours. It should be much more than enough. Normally, for stream data, after you put to the stream, your consumer, all right, should get those data and process within seconds, okay, maybe minutes. So hours is much more than enough, all right. But we can extend to 7 days, and then you pay for that extension, okay. So when we go back to Kinesis, oh, Kinesis pricing, and then data stream, you pay for SHA hour. You have one SHA. Remember yesterday is Monday. Remember Monday, you can every SHA 1 meg write, 2 meg consume. All right, 1 meg write, 2 meg read. Okay, so you pay for SHA hour. You got more SHA, 10 SHA, so that's 10 times more. All right, the pricing. So and then you can select region once again. Singapore, SHA hour. You pay for this one, and then you also pay for the service. The service is yeah, the payload that you upload is for they measure by every 25 KB. Suppose your data, your stream data is 5K, you pay for one put payload unit. Okay, even if you have 5K, you pay for 25K. All right, so it's easy. If you got 45K, then 2 payload unit. Okay, because we can at most have 50, and then 1 meg, simple calculation, divided by 25, then 40 put payload unit, and the price for put payload unit is like this. Okay, you pay around 2 cents for a million unit. Okay, and of course you need the calculator help you. All right, and then extend, you pay for this amount. All right, so this is related to Kinesis, and then this is for data stream. Just what this is basically everything from the official page, still the same. Okay, 5 years before, still the same. 1 meg input, 2 meg per second output. We can 25K, round up 25K, and then you pay for every million. And then if you want to extend to 2 days, 7 days, then to pay for that extended SHA hour. All right, but normally 24 hours should be enough. This is real-time stream data. Okay, and Firehose, yeah, you can take a look on the Firehose pricing. Sorry, go back to my Google Chrome. Kinesis Firehose pricing. Okay, yeah, here data ingress per gig, then you pay for that. You got more and more data, you pay at a lower rate. Okay, over 5 petabyte, they ask talk to AWS, talk to the business development manager. All right, and then some calculation example. So you pay for data ingress. Okay, so this is related to Firehose. Okay, so they round up to nearly 5 KB, and then data ingress. Okay, use the pricing calculator for that. So this is once again actually from the pricing page. Okay, so suppose in US East, and then 3K, round up to 5K. When we do the calculation, we use this one. How many data ingress per second per month? Then you pay for 400 US dollar. All right. So just do the calculation. And then data analytic is Kinesis process unit. Yeah, it depends on how much resources that you use. Once again, go back to the Google Chrome, search the Kinesis data analytic pricing. And then here, they got some example. Once again, Singapore, your application per hour, 13 cents. Okay, and then take a look. They just grabbed the example from here. Yeah, 30 days, 24 hours. Think about, once again, do we need to have that application 24 hours? If not, if nighttime, you don't need that, then you better turn off. All right, terminate. All right, so do the calculation, a few hundred in this case. Now we have Frank, and then yeah, you take a look on all the pricing. Okay, now we have Think, and then also the SQL, run on legacy SQL. The pricing is a little bit different. Okay, check the official page. So this serverless technology based on your usage. And then DynamoDB. DynamoDB, we pay for storage, and we also pay for the read-write capacity unit. And nowadays, we have a relatively new pricing model, on demand. Okay, on demand, you pay for actual read and write. Okay, as we mentioned before, traditionally, your EC2 and then talk to DynamoDB, you pay for the throughput. The technical terms is read the data, read capacity unit. Okay, write the data, write capacity unit. I can give you the actual number. One read capacity unit means 8K per second. Okay, by default. And then write capacity unit is 1K per second. So if you need to write the data to DynamoDB 1 megabyte, then you need 1,000 write capacity unit. Okay, and then the throughput, the pipe is much bigger, then you pay more. So if you exceed this throughput, what will they do? They will throw an error 400. Okay, your provision throughput floating. Then normally your application need to retry. Okay, I failed to write because all the throughput used out. All right, floating, and then retry again. If the pipe is full, keep floating, keep retry, it slow down your process. All right, so what we can do is we can use auto scaling instead of manually set a number. Your traffic, you don't know. Okay, then we can allow auto scaling, increase the throughput and reduce the throughput, yeah, automatically. All right, this is traditional how we pay DynamoDB. And then on demand means by using on demand, you pay for actual read write, okay, not this pipeline, not the throughput. But if you continuously, okay, keep sending data, write the data to database, keep reading, it is more expensive. Just like EC2 instance, on demand is more expensive than reserved instance. Now, on demand is more expensive than the provision throughput. But by using on demand, you will not see any floating error because this is not a limited throughput. Okay, you can read write anytime you want. However, some scenario by using on demand is very good if is that the spiky traffic. I actually got one project also related to financial. Every minute they need to record a stock price. Okay, 300 stock every minute. Okay, write the stop price, 901, write the stop price, 902, write the stop price. So in that case, we might need a very thick pipeline in order to avoid the floating. And then for every minute, maybe just 1 or 2 seconds, we write the data. And then the remaining 58 seconds is very idle. So using a provision throughput is not ideal. So in that case, using on demand is perfect. Okay, not only the project save a lot, but also will not throw error. But in many other cases, if you keep writing to DynamoDB, on demand is not a good choice. Okay, so really depends on your pattern. By default, you can create provision throughput. I just want to show you a little bit related to this settings. Very quickly, I go to DynamoDB, just show you how you select this different pricing model. DynamoDB first button, create table. We don't need to provision. Instead of select default, you can select on demand. All right, you pay for actual read and write. I did some calculation in previous project before. If you continuous write the data, comparing with provision, I think it's around 30, 40, around 40, 50% more expensive. Okay, but yeah, for spiky traffic, this one, provision, throughput, if you don't need auto scaling, our read and write super stable. Okay, then you set the number. All right, one. Okay, as I said, 8K per second, 1K per second. Okay, suppose you need a 800K, then 100 read capacity unit. Okay, or you can use auto scaling. Okay, so this is related to provision throughput. And DynamoDB, you can create index. Of course, you also need to pay for the index. Okay, index is basically another copy of the data, because in DynamoDB, we cannot just query the non-key attribute. Okay, some of you very familiar with DynamoDB, but some other may not. In DynamoDB, say for example, we have ID, we have name, we have country, we have some other column. I should not say column because this is NoSQL. I should say this one is attribute and this is item, not column and record, because column and record is very fixed. Okay, but attributes is not fixed. We don't have fixed schema. Okay, maybe this item I store some attribute, the other item I store some other attribute. All right, so come back here. In DynamoDB, you cannot just query non-key attribute. Suppose this is country. I just want to select all the country and summarize which country do the best, which product sell the most. You cannot just write those query. Okay, because every query we need to use the ID. Okay, the other approach is you can scan all the data and then filter out all the data. It is possible to do so, but think about DynamoDB is distributed database. Okay, your data across AZ, maybe you got billions of record, billions of items, sorry, in the table, and then you query out, and finally, I just want 10. This is not a good method by using just scan. Okay, so a better approach is we create a secondary index, and then we say for example here, make all the country here, okay, and then all the amounts here, and then you use once again the primary key to be more specific, partition key and sort key in order to do those query. So you actually likely dump a set of data to looks like another table, but actually we call it secondary index, and then you query here. All right, so since you dump another data set here, you need to pay for that storage. Okay, and yeah, you also pay for that read-write capacity unit. Okay, so take a look on their pricing. And DynamoDB, we support data stream. Data stream is basically just change of the data. All right. In the DynamoDB table, you may change something. Okay. So yeah, you can have another endpoint and then query, take a look on those string. It's just stream data. All right. Traditionally, we use this stream to have another read replica. Okay. DynamoDB originally you can have read replica in another region. We use the stream. Okay, send those change to those read replica, and I think 2.5 years before they change it to global table. So not only read, but you can write. Okay, you write here, and then replicate. You write here, replicate to here. Okay, they use the stream. Now you can go inside and take a look on the stream. Think about if you are a database guy, the DynamoDB stream together with Lambda function. This is actually database trigger. All right, insert update delete trigger. All right, so this is a database stream that you can have endpoint, and yeah, this is related to the changes. You also need to pay for that. And DynamoDB, as I mentioned, we support auto scaling. Scale the throughput. Scale the throughput. Okay. So if the throughput use 80% for how many minutes, then scale out. We can also set maximum and the maximum throughput so that to save your pocket. All right. So this is related to DynamoDB. And Redshift. Redshift, once again, it depends on which node type you are going to use. Some of them could be as cheap as 1 coffee every day. But yeah, if you want RA3, RA3 is, I can show you the pricing. Very powerful, so a little bit more expensive. If you go to take a look on Redshift pricing, then yeah, we got 3 generation or type nowadays. This is legacy. Okay, compute focus. This table is very good. Let me just put it into our Slack group for the course related to DynamoDB. Suppose you are using DC2. This is the cheapest. As you can see the price. Okay, 0.33. A coffee every day is this one. Okay, but if you want more powerful, okay, 2 CPU, 15 gig RAM, as I mentioned before. Now this one super powerful, 32 CPU, 200 RAM, and then much more storage. That's why much more expensive. Okay, and then focus on storage. And if you use RA3, then you see the price could be more expensive. Okay, so take a look, compare all those pricing, and yeah, we can have 128 node using this. Okay, but for this compute, dense compute, maybe at most only 32 node. So not 8 petabyte. You need to do the calculation. 160 gig and then times 32 node. That's the maximum data that you can store inside this Redshift cluster. Okay, still calculation. And yeah, could be as cheap as 1 coffee a day, but if you choose some more powerful machine, could be a Ferrari every month. Okay, so next, the pricing model, you can use on demand. You can also sign contract, so that yeah, much lower. Talk to the solution architect, BDM. I think in that case, use compression so that the same Redshift cluster you can store more data because of compression. Okay, and then nowadays we can move the result, the data back to S3. Suppose Redshift, I just keep the current 10 year. All right, this is 2021. I just keep every data before 2010, 2009, move back to S3. Okay, so to so that you don't need that much, that many node and that big instance type to reduce the cost. So now we don't have just these two. We have RA3. Okay, RA3 have a lot of enhancement. Okay, it's super powerful, but you pay more. And then Redshift Spectrum. Okay, store the data back to S3. Still very structured data. Still, you can use Pacrete, ORC, something like that. But this is what we call external table. We can use a single query to join those tables inside Redshift and together with this Spectrum. It means that some data in S3, some data in Redshift, I talk to Redshift, the two tables you can join together, just like our normal SQL statement. Okay, we can do something like that, but here, a little bit more on the latence, okay? Because the Redshift cluster, you need to talk to external guy. Originally, all the data is inside those Redshift local disks. So best practice, yeah, nowadays we say query reporting rather than ELT, okay? I haven't talked about this term for a long, long time, okay? 8 years before, 6 years before, we talk about ELT, load the data into Redshift and transform. Don't do it anymore. And then copy, use copy command, okay? Aggregate the data before you copy. And then consideration, yeah, think about the data in S3, if this is not transactional, and then the number of data scanned, you pay for the data that you scan. So think about this for Spectrum. Do we still need to query those data? If not, or if sometime, then good candidate move back to Spectrum rather than saving inside Redshift. Redshift is much, much more expensive than S3. I'm not saying Redshift is expensive, but S3 is very cheap. And then, yeah, optimize the cost. Once again, comparing with on-prem, you should save a lot because you don't need to invest on the hardware, the shared storage. Yeah, this is for a new project using cloud. I think at least you should save 50% comparing with you build the data center, do it on-prem. That's the TCO calculation, total cost of ownership. All right, we have the TCO calculator comparing with running on AWS with your on-prem. We should save at least 50%. Okay, then take a look on whether you upfront, if you pay everything in day one, that's the cheapest. But not many companies want to do that. Okay, they want to have a monthly partial payment, and then select the right choice. Sometimes I just change, okay, to another payment method. Then you save a lot, and then take a look on some price reduction. This one you talk to the sales. Sometimes if in the quarter end they cannot meet their target, they could have a huge discount, give you a lot of credit. So it really depends on different office region. Okay, so you use more, then you go to another tier, you save more. So this whole module is related to cost. Yeah, long running cluster. Take a look here. Yeah, what kind of big data circumstance good for spot instance? All right, spot instance. No, if you were using long running cluster, yeah, you are paying every single second, 24 hours a day. So if you can use spot, then you save really a lot. Okay, yeah, and then testing is also good for spot instance. Just anything your cluster could fail. All right, and then when you launch EMR, you pay for both EC2 and EMR. Yes, you don't just pay for EC2, you have a certain percentage, maybe 10, 15, 20% for the EMR. Every instance is a little bit different. Okay, you can leverage spot instance with EMR, and then both EC2 and EMR will be reduced. No, EMR, the price is fixed. Okay, you only save for EC2. Only EC2 that part will be saved. Okay, so this is related to the cost, and then what service you can take a look, seeing underutilized, overutilized CloudWatch. After you do the monitoring, if in the monitoring you see the CPU usage, memory usage, if you do the custom monitoring, is just always 10%, 20%, it means that maybe you can lower the instant type. If the usage is over 80% for all the time, then maybe you need to adjust to another instant type. Okay, so NoSQL, you need to patch the OS? Of course not. Okay, for DynamoDB AWS managed service, you don't need to do the maintenance, the patching. It also saves you some costs on admin costs, all right, because you don't need to hire some person to do the maintenance. Okay, so this we also need to calculate, all right. And then for Kinesis, we pay, yeah, we call it, we just saw it before, put payload unit, all right. So reference all the service, there is pricing page. Kinesis, DynamoDB, Redshift, actually I just visit almost every page. Yeah, and the calculator, pricing calculator for the estimate, the monthly money that you are going to pay. ECO is comparing if you do it on-prem and AWS cloud, normally how much you save using AWS. All right, Trust Advisor give you some advice recommendation. And nowadays, many area you can see recommendation. You can go to Compute Optimizer in your CORS Explorer. You can also take a look. Let me show you a little bit on CORS Explorer. If I go to, let me just close some. Okay, CORS Explorer. And then you can understand what you are paying and do some analyze. Yeah, this is my account. Okay, as I showed you here, you can adjust. I just want to take a look on the last 2 months. You can change, all right? And then every day, how much you spend, which service. And for this 2 months, what are the total? Okay, my AWS account just for me to do the demo purpose. And then you can understand the ELB, the S3, you see the Kinesis. Okay, for this several days, I forgot to delete the Kinesis. Okay, and then I found that here. So after that, I delete the Kinesis application. So anything abnormal. And as we mentioned, we better use tagging. Okay, so if you go to tagging, for a single project, then how much you spend, you can apply. Say for example, just $4 for this project. Another project, by using tagging, maybe use $100. So you can analyze based on your customized tagging. So this is related to cost, but most likely the financial guy, project manager work together. Okay, and technically, a lot of our students cannot see the billing CORS Explorer, that page. Depends on whether you have permission on that or not. So any questions related to coursing? Can you actually see the coursing? Everybody? Anybody? Can you touch anything on coursing? Anyone? Do you have permission on coursing? Yes, that's good, Jesse. A personal account. All right. Thank you very much. Let me talk a little bit more. Before we take a short break. One more module is related to visualization. Okay, so we have a lab here, but we will do the lab a little bit later. Okay, so visualization, uh, same pipeline. Let me, yeah, we are talking about visualization. Our focus is here. Okay, before ingress, collect, inject, no matter how you say it, we talk about storage, module 4, and process. Okay, a lot of the topic related to process, Athena, EML, Spark, Glue. Okay, now the final part of the pipeline, visualization. Okay, and maybe this one is the most important because the boss, the VIP, they take a look on the report. We are not going to give them 5,000 page, but it's summarized report. Okay, so let's take a look, and then we will take a short break. Visualization. Okay, for many companies, they try to find how can we increase the revenue, save the cost, more optimize our target customer, product, and as I said, nowadays not just business, a lot of health company, uh, yeah, also crime investigation, as I mentioned, government, they also use this. Think about NASA, they may also use a lot of. NASA is also a very big AWS customer. All right, so not just profit. Okay, answer decision. Then we see a lot of graph. Okay, so depends on how you want to present those data to the VIP. Okay, so we got lots of data, not the raw data. We already processed. We already ready. Get ready to share the insight, what we find to the important guy. Okay, so to answer question, what is our target customer? How much products should we produce? What device should we use? Yeah, something like that. Okay, so cost and time also affect visualization. Okay, I don't want to generate the report, take 2 days, and then 2 days later, and then you can take a look on the report. Hopefully, the manager can run the report almost immediately. They can get the most updated data. All right, and then cost is also important. All right, so AWS, that's why they create this QuickSight a few years before already. As instructor, honestly, we all recommend AWS training team to produce a QuickSight lab, but we asked for more than 5 years, still not yet available. One key question is that QuickSight is not in pay together with your AWS account. It's another subscription. Okay, another product, another team. All right, so that's why this lab we still use some third party. Okay, 5 years before we use third party. Now we still use third party. Hopefully, one day we can do some QuickSight lab. Uh, anyway, but in our lab we use third party Spotfire. This is a cloud-based QuickSight provided by Amazon, cloud-based BI tool, and then they say the price is very low, but you need subscription. Okay, subscribe enterprise and then or standard. Yeah, it can integrate with many third-party solution. All right, but many people use this third-party solution. Yeah, for these 2 years, I really have a lot of customer use Tableau. Okay, and Tableau is very close with AWS. I don't know whether you know it or not. Their boss, Amazon, the boss, Jeff Bezos, is stepping down. The AWS boss, Andy Jassy, will take over the Amazon, the CEO, the role. And who take over the AWS? Uh, the the owner, the CEO of Tableau, will come back and then become the boss. So they are super very close. But anyway, Tableau is another very famous BI tools provided by uh, other company. All right. So here is QuickSight. Let's take a look on QuickSight. We can create interactive report dashboard, very rich. So they suggest QuickSight is very fast. Actually, it's not just very fast. It spikes super fast. Uh, yeah, super fast parallel processing. The engine. All right. So this is spikes. They focus on parallel processing. I means in memory. Okay. Why it is fast? Because both parallel and in-memory processing. Okay, and then we support many source. You can actually have the source in S3 in Athena, but think about if those data in relational database RDS they are not processed, so they are just very raw. Okay, of course you can do the process here, but if you do more and more job here, it takes longer and longer to generate those reports. So we better process the data and then display to the user directly, so that the user do not need to wait for any further seconds. Okay, so easy to use. It's just BI tools scale effortless. All right, it's just like the serverless technology, and then very low cost comparing with other party like many years before I used the Crystal Report, Business Object, ClickView. They are all expensive. Okay, so visualization. You if you want to take a look further, yeah, you can no matter YouTube or you can create a child account, work with those QuickSight. We have once again the line chart, bar chart, and then just like many other visualization tools and service. We support rich data type, rich data source. We have a lot of different presentation graph, something like that. As you can take a look, the QuickSight, we can integrate it with many party. But think about it. This is OLTP, our transactional raw data. Okay, if we connect here, maybe we need a lot of massage process, and then it takes longer. Even in memory, it takes longer to have your report. Okay, we can connect to Athena S3, but I think the best way is go to Redshift because already we finished processing. We just get the result and then serve the world. And we can support third-party source, Spark, Presto, and Progress Database, and some other. All right, not only AWS, but third-party integration. Super fast in memory calculator engine. That's why we call it spikes. Okay, rich calculation, fast response, fully managed. You just pay for the license, and then you can collaborate, share. There are two license that we can buy, consume, subscribe. If you take a look on AWS, I should say Amazon QuickSight pricing. And then you can see standard, all right, $9 per user per month. Enterprise, okay, what you got for enterprise? You need to, for enterprise, you can link with, say, for example, AD, authentication. You can do a lot more that we need to take a look on their documentation, okay? And then, yeah, so you can share, collaborate, publish the data, okay, to any website or your mobile phone application. So this is QuickSight. Yeah, give it a try if you are those data guy. And then other third-party tools, Tableau, very famous. Okay, I don't know whether you use it before. Can integrate with many other platform. Can work with Redshift, RDS, EMR. Our lab, we are going to use this Spotfire. Okay, and then Jaspersoft is just another choice. So we got some third party. Of course, you can use some other tools like the Power BI, a lot more. All right. So this module, we take a look on the yeah the application yeah, the big data workflow, uh, the two application that we schedule big data workflow uh, from open source is OZ, and we talk about data pipeline. And now uh, for other workflow, you think about the step function, okay? And then the data pipeline, actually under the cover, they use a simple workflow service. This is very relatively old service. Okay, data pipeline is built on top of that. And then QuickSight is very fast cloud-based BI service. Lastly, and then to visualize the data, we use the structured data, SQL, okay, query performance, integrity, and then pre-processing. All right. So in your ebook, you have all this question and answer. You can review anytime later. Uh, yeah, for the lab, we use this Spotfire, just one of the visualization tools, display the line chart, pie chart, bar chart. Okay. So this is module um, 15. Okay. Do you have any questions? If no question, let's take a relatively short break. Come back 3:50. Okay, and then uh, I will wrap up the class. Let's take a break first. Yeah, 3:50. Okay. Yeah, just now 350. Let's move on. We still have a couple slide related to this course, web and some design architecture. You can find this in your ebook, and then once again, go to case study, go to this is my architecture. You can find some more. This is just example, all right? This module, uh, yeah, we take a look on some design pattern. Many AWS customer uh, build a BI with similar example. So multiple AWS service to build the solution, right? Once again, we must see those pipeline. But in the middle, we may use different service. Let's say interactive query. You can use S3 Athena, or you can use the EML together with Spark. Okay, so how you are going to visualize? You can use everything provided by AWS or link with some third party. Just like in this training, some of you already familiar with Kafka. Some of you already with familiar with other reporting tools. So this is just common example. Okay, architecture example. So for interactive query, let's take a look on how it looks like, especially before 2016, 17. At that time, we don't have Athena, right? So you have a lot of log file. Let's say this example, terabyte of log file every day. Okay, maybe from your application log, uh, public facing web log, whatever. All right, we store it in S3. So how you store, you can use a wide range of method. You can use third party. You can use from AWS. Even Firehose, you have the agent, the producer, Kinesis agent, producer library, and then use Firehose stream to S3. Let's say, all right, or use from use log4j third party. Just we have the log here, and then we can spin up EML, multiple cluster for different project, different team. Unlike transition on-prem environment, you have a big giant cluster for different department, different project. And then we have the Hive Metastore, and then we use different type of interactive query. Like if you use SQL, Postal, and Hive, all right, Hive based on nowadays the default engine is fast, much faster than running on MapReduce. Even Spark, you can use interactive query. We got Spark SQL, right? So you can do something like that. However, if you find this is quite difficult, I don't want EML, you can use Athena. Later on, we have this approach, another diagram. So batch processing, once again, you have the log file. Say, for example, every hour we push the log into S3, whatever method that you use, and then we process the data daily. Maybe at the end of the trading day, then we process those data. And then after that, we use Redshift. We store the result in Redshift. Raw data here. And then after you process, maybe still have some unstructured, semi-structured data stored in S3, very structured, stored in Redshift. You may spin up the EML cluster at midnight. Maybe that time the spot price is lower. All right, 2 a.m. You finish the job by 4 or 5 a.m. And then every day, every night, you only use the EML for 2 or 3 hours. It is possible to do so. Okay, when there is daily, hourly transaction, we may not to process every single minute. All right, so it is batch processing. We have some interval, do it every night, every week. So stream processing, you have your stream source, maybe mobile device, maybe IoT device. So in nearly real time, if you want to have to respond so fast, we use Kinesis Stream, or once again, you can use third-party uh, stream service. And then suppose you use Kinesis Data Stream, it means that we need to have some application to process. You may use the client library since you may have some application running on EC2 containerized application. Use EC2 to process, and then Lambda function to process, or even EMR to process. Inside EMR, once again, you can use Spark streaming, or we can still leverage some Hive and Pig or Storm, all right, third party. Just check the box, install, and use those third party application framework to process those stream data. And then for real time, because real time we focus on fast, maybe bidding, maybe some trading. We use maybe DynamoDB, the application pass data in the DynamoDB, and then event-driven, as long as some data insert into DynamoDB, and then Lambda function. Okay, and you may also use some machine learning, no matter from AWS or third party, then SageMaker, okay, and then process those prediction, real-time prediction. And then batch prediction, when you take a look on prediction, always refer to ML, maybe nowadays SageMaker. And then those data, we very structure store it in Redshift, and then the result we store in S3. So this is just another method. Okay, so nowadays, many people use more and more machine learning. AWS, we have those, but in another course. And then interactive query, just like the first scenario. We don't want to spin up EMR. Okay, just like some of you use SQL statement, query those data in S3. Then Athena is perfectly fine. Okay, for serverless storage, serverless processing. Okay, so that you have interactive ad hoc query. All right, and long running cluster. Luckily, we have a lot of team, a lot of project running, maybe every hour. Then we have some process that we need, some pig, some HBase. That's the distributed NoSQL statement, NoSQL running. So we keep having the real-time dashboard report on what happening related to your business. So you can have long-running cluster on that, on the EML cluster. And then next, log cleansing. Okay, as many application business, they have event that all these events store in the log. So you may use Kafka for people to upload those log. At the end, save in S3, and then we may do some aggregation. Okay, and then you might also need to do some transformation, and that's the point of using EMR. After you do the transformation, ready for Redshift, ready for data warehouse, for analytic, then put it here. And then after that, some other transformation, you may use Hive, store in another S3 bucket, and then use EML, generate another output. So here, as you can see, storage, and then process storage, and storage process, so that you have some aggregated data. Based on Amazon, they have some by hour summarization. Okay, every 2 hours they summarize, every day they summarize, every month they summarize. Okay, so that you can take a look on different kinds of report for the business decision making. But how can we build this? Okay, how can we build all this? Okay, as you can see, you have S3 data lake, you have Elasticsearch, QuickSight, so many things. Nobody is expert on everything, right? So that's why AWS have the quick start for the customer. If you go to AWS quick start, these are created, the CloudFormation template created by AWS Solution Architect. Okay, let's say EMR. There are many. Oh, nothing. How come? Big data. Okay, if you search better search big data. So this is from Databricks. Okay, they use together with built by Databricks and AWS. That's perfect. But you still get other template. This one work with Splunk, and then Tableau, right? SAS. Okay, so you can find something. This is just CloudFormation template. If you go to, say, for example, Databricks, this is what we are going to do. Okay, they will build the Databricks cluster, all right, and then together with public private subnet integrated with CloudWatch, KMS. If you don't like this one, I want something, let's say IBM, okay, together with IBM. They build something like it so that you don't need to do everything on your own. Normally, this is just CloudFormation template. You can use the CloudFormation, spin up the whole things, or you can change the CloudFormation. Okay, it will be easier than what you write from scratch. From the quick start, you can find something like that. Okay, so that some of them maybe they are already using Elastic MapReduce, Athena, Kinesis. They did everything, okay, for you. Okay, just try to find. There is around 400 uh, uh, template at the moment. Okay, and then you can also use Groove, okay, to do the transformation, do the ETL, maybe from one region to another region, from one data source. At the end, I save all the result to Redshift. Don't use Redshift to do the transformation anymore. All right, so yeah, of course, because they both live inside VPC. I mean, the the Redshift and EMR, if you have, then there is a lot of configuration related to security group, VPC, private subnet, public subnet, something like that. So yeah, you can also find some quick inside the quick start. Okay, so you don't need to do everything on your own. And we got some appendix in your book. This is very old resources. Okay, but this is for your further reading. Okay, yeah, as you can see, just like this page, cold data. What is cold data? What is hot data? Stream data, Kinesis, Kafka, they are considered hot data. And then DynamoDB in the middle, S3, yeah, that's relatively cold. Hive is relatively cold. So you can take a look on further appendix reading. And let me wrap up the class, and then we will yeah, complete the class, and then all the remaining time will be the lab. So the last module is just review. Okay, this 3 day we talk about the big data, the pipeline, and then the big data ecosystem. Yeah, there are many service, storage service, database service, processing service. Because AWS got millions of customers. Some of them just use Athena. All right, some of them maybe use EMR together with some Hadoop project. So yeah, Hadoop is very important. If you go to examination, the EMR, Pig, Hive, you will see all those questions. But we know the position. EMR is the AWS version of Hadoop. You can just check the box and install all those applications. But how to use those applications? Of course, you need to take a look on third-party white paper. Like Spark, you need to go to Databricks, Hive, Pig, something like that, the Hadoop ecosystem. We got many components. And then we discussed how we are going to launch the cluster. Master node, core node, if you want to have some more compute resources, the task node, and then the programming framework. We know the most famous framework like Spark, Hive, and Pig, the difference. Hive for query the data, Pig for transform the data, and then different web interface. Jupyter Notebook for Python user, and then Hood for the Hadoop interface. All right, something like that. And then in-memory analytic using Spark. Postal also here, but the difference is Postal we need to load all the data into Coastal. Spark can work with this high scalable. And then the Athena and different types of storage, unstructured, structure, yeah, the position of S3, DynamoDB, RDS, and also Redshift. We also discussed a little bit on Redshift, but Redshift we've got much more. And then benefit of using Kinesis for real time. Then you just install the agent, use the library, and then you can stream all those data. And we got test data for you to write your stream, write your application, try it out. And then Glue for ETL and also data catalog. And Redshift, the position is data warehouse. Normally, after you process, you store those results in this analytic database, right, for historical data. And then we just talk about cost and security. Sometimes we change the pricing model. Sometimes we change to other service. You save a lot, all right? Security, once again, is very important. Depends on whether you use the service inside VPC or not. If they are inside VPC, you can use the security group, network access control list, private subnet to protect. But if you're using DynamoDB S3, they're not living inside VPC, then they have some other features to protect, like the server-side encryption, access control, IAM bucket policy, and then the encryption endpoint, something like that. And then for transfer data, how we ingress the data, yeah, could be stream data, Kinesis agent, or we talk about the multi-part upload through Direct Connect, VPN, Slowball, but that for runtime migration, Slowball, Slow Mobile. And visualization, we have a wide range of product that we support. AWS, QuickSight, or third party, Tableau, Spotfire, and some more. All right, orchestration, we can use data pipeline. This focus on data, but for other product that related to step function, that one not just data. Normally, step function integrated with Lambda function. Okay, but both can be used to orchestrate your work. If you got on-prem data, data pipeline focus on data movement. So if you have this scenario, this is a very good choice. But if you just want to do the ETL, maybe you can consider Glue as well. All right. So yeah, let's take a look on your attendance cert. Please go to this website. Let me get it once more. Now you are going to get your attendance cert. Where is the link? Too many here. Let me just find it again. Please log into aws.training with your register account and password. Please do it now. Yeah. Let me share once again. You can just go to AWS training or log in directly here. And let me show you. Okay, go to aws.training. So login, my screen is a little bit different because I'm not a student registered into the class. I just show you something similar. You go to transcript. Excuse me. And then you should now see the course big data on AWS in archive, right? Can you see that? Can somebody tell me whether it is in current or archive? Yeah, very good. Yeah, archive. Archive mean the admin already mark you complete, finish the class, and then you should see the attendance cert here, completion cert. Can you see the completion cert? How about the others? Let's say Elvin, William, Roger, Eric, Grace. Can you see that? Everybody? This is, yeah, very good. And then uh, some of you mentioned before, if you want to have this name change to your ID, wherever, because you need to claim the money, wherever, you can go to here. I show you how to change my account profile. All right. And then here you change the name. Let me say ABC, save. And then go back to transcript. You will see that it become ABC. Okay, almost immediately, real time. Okay, of course, I change back to my name. So here is how you change the display name. They don't have a button save. You just clean screen so that show it to your boss. You finish the training, not go to play something like that. Okay, so everybody got the attendance cert, right? Okay, one last thing to do officially is that is very important to me is the evaluation. If you go into evaluation, you will see something extremely satisfied or satisfied. Extremely satisfied means 5 mark. Here I mean 4 mark. If you see 10, and yeah, this is extremely likely. The standard I show you by AWS. Let me show you. Please wait. The AWS standard is super high. We need 4.5 in order to pass a class. So it means that if you just satisfy, I'm failed. All right. So I hope you understand the standard. So please fill the evaluation carefully. All right. Please fill it now. Okay, have you finished filling the evaluation survey form? Everybody? Anyone still filling the form? Anyone finish? Okay, thank you. How about the others? So if you finish filling the form, the remaining things is optional, totally optional. Okay. Personally, I have a student group. Uh, because the Slack, uh, once again, you can ask question until September 30. Okay, this is the date that remind me to delete so that you cannot access anymore. Uh, yeah, just like yeah, this one September 30. So if you are interested, you can scan the QR code I show you later. I've got a private Facebook and MeWe group. Uh, I got 300 member. They are all my student. This is a private group that only my student I will approve and then join. And periodically, I will, yeah, you can ask question here, but periodically, I will, yeah, post something. Some of them I think is quite good, the announcement, and then some of them maybe some event, some webinars, some workshops run by AWS Hong Kong. You can join. You have you may also get some credit or some souvenir. All right, so I will just keep posting. Yeah, maybe every day, not every day, maybe every week, every month. And yeah, after this is the class I complete last week. Next week, I'm also teaching advanced architecting. So the member is becoming more and more. If you are interested to join, the left hand side is Facebook, right hand side is me, but it's totally optional. Okay, I just give you 20 seconds. If you want to join, make a request now. I will approve so that we can discuss further. No time limit. And actually, last week, some people, some company want to hire some dev set up guy. Yeah, they are going to post something like that in the group. Yeah. So yeah, if that's interest, then please join. Yeah. 10 more seconds. Okay. Uh, huh? 503 error. How come? Let me just double check. Oh no, sorry. I know. I used a wrong QR code. That's not Facebook. Let me do it again. Sorry. The valid. Uh, should be this one. Sorry about that. Yeah. Left one. Left Facebook. Right. Miri. Is that okay now? Let me double check. This is my other screen. Yeah, okay. I see somebody already make the request. So should be all right now. Gideon, William. Okay. So final thing before we do the lab, uh, is that one last thing. Again, optional. Is that if you are interested, you can turn on the camera now. Just like this is me, this is some other student. Some of them they don't have camera. Some of them not interested. It doesn't matter. All right. So last week I have a physical class. Uh, yeah, it's architecting. So that we really draw the diagram, we present, and then keep questioning. Quite interesting. I haven't got physical class for many months. Okay, more than 1.5 years. All right. So, yeah, if you are interested, you can turn on. Thank you, Darren. You can turn on the camera now, and we take a photo. But if not, it doesn't matter. Yeah, I got. Thank you, Jess. You're both from Malaysia, right?
Yes.
Okay. How about the Hong Kong people? You are not interested, right? Just a few more seconds. Yeah, we got more people. Thank you. All right. Thank you, Kevin. Yeah, 10 more seconds. How about we have a like so that we become happy? Please hold because there is delay in Webex. 1, 2, 3. Okay, so you can turn off your camera now. Thank you very much. So, I think this is all that I need to talk about. Let me post this into our group. Yeah, just yeah, in this channel. Uh, and then the remaining time will be all the lab. Okay. We didn't do the lab 7. It takes around 45 minutes. If you finish the lab, it's already 5 something. You can do it now. If you got question, you can ask now or later in Slack, tomorrow, next week in Slack, next month in Slack. I hope you guys enjoy the training. Hopefully, I can see you sometimes later. If you finish the lab or you want to do it later, you can leave anytime. All right. So yeah, do you have any question? Want to ask me now? Anybody? Interesting. What is Canfield? Uh, I tell you a secret. I'm not really AWS staff. I'm an authorized instructor working in this company. Okay. But since I'm the first guy in Hong Kong to deliver AWS training, uh, I'm the major guy, especially teaching some advanced course. You saw the email. How? Oh, all right. Doesn't matter. Okay. Even in many big event, seminar, workshop, webinar, I help AWS Hong Kong to do it. All right. So, do you have some other questions? Yeah. If you don't have any questions, you can leave anytime. You can do the lab. Yeah. Hopefully, we can someday see each other physically. Thank you very much.